Hello, everyone, and welcome to Java on Conference day number 3. We're glad that you are still with us. We hope you had 2 great days, and today is the day number 3, and I'm pretty sure it would be great as well as previous 2 days. So I won't be alone today as previous 2 days, and I would like to invite here to the stream my co-host for today, Alexander Barmin. Alexander, welcome to Java on Conference.
Hello everyone, hello Roman, thank you very much for having me today. I hope it will be a fantastic day, despite the fact that it is the last one day of the conference. We have star speakers today who will share outstanding news. Like Apple say, it will be an immersive experience for everyone. You will definitely enjoy having it.
For sure, for sure. As also Apple say, I am terrified about that. So before we start, let's remind our audience something that could be important during watch of our conference. So yeah, this is Java On from 15th to 17th of September. Today is the last day, as we already mentioned. We had great day on Wednesday, 3 wonderful talks, and also there was great day yesterday. Both streams you can find on our YouTube channel or on the VR community platform, where you also can watch us right now. And this is today we have 4 wonderful speakers. We will start with Javokhir, then we will go with Hunar, then with Adam, and we will finish with this day with wonderful Josh Long and his speech about Spring Boot 3. Also, I want to remind you that we have Instagram account. Sasha, are you subscribed to our Instagram?
Definitely. I am subscribed and I'm getting notifications every day. And also I'm getting invites from our speakers and invites from our committee. Everyone is awesome. Everything is extremely fantastic.
Yeah, for sure. So we have a lot of things there. We have there some shorts, some posts, and posts from our audience. Thank you very much for being with us there. Also, we have account on X. I still call it Twitter. We also do some announcement there, so please subscribe. All accounts you can find during the conference here above me, so you will never miss it if you don't have a time to scan QR code right now. Also, we still have online activities, and this is your last chance to win some prizes. So we have a contest for a photo in Instagram. So you just need to make a photo, post it to Instagram, and tag us. Here you can find tag on Instagram, and you will have a chance to have a prize. And also we have 2 quizzes which you can take part in and win prizes as well. So yeah, as I mentioned before, don't miss this chance. I do understand that somebody missed this information. So guys, we have prizes this year as well as previous years, so you have a chance to win them. So that's what I wanted to remind to our audience, and we are waiting for our first speaker to join us here in our virtual room. So this will be Javokhir. We will ask him to turn on his camera. Yes, he is with us, so please bring him to us in our virtual studio. Hello, Javokhir. How are you?
Hey guys, yeah, I'm good, thank you. How about you?
Good. Thank you very much. So we will start day number 3 with your talk. Can you maybe tell us a couple words? What would it be about?
Well, it would be about a microservice pattern, so mainly about a sidecar pattern. And we will talk about a sidecar pattern by seeing an example as using the Envoy proxy pattern. And we are going to have some coding examples as well. So it's not going to be just like a live coding, I would say, but it would be like we would go through the code example and see, make some requests to our systems and see how it works. But we will start by giving some technical background about what the sidecar is, why we need it, and what is the Envoy of it, and what kind of different implementations of sidecar do we have. And then we will move to the workshop part and then to the QA part. Yeah, thank you.
Okay, that's wonderful. So we would ask you to share your screen, and meanwhile you're sharing, I want to remind our audience that we have 2 chats where we collecting your questions, your reactions, anything you want to share with us, and I do really encourage you to share it with us. It's an online conference. We cannot see you, unfortunately, but we still want to hear from you. We want to feel you near us. So please use this opportunity. We have chat on YouTube right here near the video where you can see us. And also we have chat on VR community platform. Me and Alexander will monitor both of these chats and try to get all your comments, all your questions, and ask them in the end of the session. So, say no more. Javokhir, good luck. Let's start, Javon, day number 3. Let's go.
Okay.
Let's get started and go ahead.
Thank you, guys. Yeah, thank you. I'm super excited to join here. Yeah. So I guess you can see my screen already.
Yes, we can see.
Yeah, I guess yes, because I can see it. So let me just introduce myself. So my name's Javokhir. So as my name suggests, I'm a Java developer. I'm from Uzbekistan, from Tashkent, and I work at EPAM as a software engineer for 1 year and 8 months. So yeah, in fact, this is my first time being on that kind of conference on that level. So I'm super excited for being here, and thanks for having me, guys. Okay, let's start. So today we're going to talk about the microservice patterns, so mainly about the sidecars, which I described already, with using examples of Envoy proxy. So here is our agenda for our topics. So we're gonna briefly talk about what is a sidecar proxy pattern is, and the key characteristics of that sidecar, and we will talk about some popular implementations of sidecar proxy, and we will go to the practical case where we'll see simple service mesh architecture, like a service-to-service communication between the two services, which we have developed using 2 different languages. So it is like a microservice architecture. So they will communicate with each other using a sidecars. And then, as a summary, I'm going to talk about the pros and cons of using the sidecars. Then we will move to the QA session. But yeah, you can actually put your QA questions in our chat, yeah, as Roman already mentioned about that. Okay, so yeah, here is a kind of popular meme about that, yeah. So let me just, I guess most of you already know about microservice architectures. A microservice is like a service which is focused primarily on the business logic. So it's not focused on, I mean, the application itself is already decomposed by the service, by the business logic it will actually achieve. So in our sidecar, we actually use the sidecar proxy patterns. In fact, the sidecar, so the translation of the sidecar is like, the motorcycle. So there is a cabin near to the motorcycle. So we call it the sidecar. So it's actually the helper to our main application. So in our case, application is just a service, so microservice. So the sidecar is the helper function for it. So we can see that, like, for example, incoming requests wanted to go to the service, but but firstly, that incoming request, we also call it ingress request as well. So I'm gonna say ingress, but you should understand it as an incoming request. So so that ingress request will be intercepted by the sidecar, and that helper functionality, which is not the core functionality of a service, will be executed. So which is, you might ask, what are the helper functionalities are? So here we can see that the sidecar, in fact, the helper service can do several tasks, such as the platform abstraction, yeah, the proxying, the services, which is pretty much the obvious, because yeah, without the proxying, how the request would go to the service itself, and logging the configuration, and also Besides of it, we do have a authentication. We can do the authentication as well, MTLS, mutual TLS termination. So all of that we can do on the sidecar level, so that it would give us so that we can focus only on the business logic on our core application. Yeah, so we don't need to implement a authorization for our every resource microservice. So it's it just gives us an opportunity to remove some kind of cumbersome code, yeah, from our main service. So our primary job would be just to develop a main application with its core business logic, and that's it. And all of that logic will be takes place inside of a sidecar, like a authorization and like logging and yeah, anything like that, which is not a kind of related to the main application's core functionality. So yeah, we can see that here are some of the popular sidecar implementations. So Envoy, Proxy Sidecar, Linkerd, and Istio. So in our example, we're gonna use a Envoy. So Envoy, it is a native written in Lua programming language. So it's actually the lightweight one, because yeah, in fact, the sidecar should be a lightweight. And Linkerd is also another implementation of a sidecar. It is a cloud native, and also it's a lightweight. And Istio is a pretty much a bit advanced version of Envoy, which gives us the whole control over our sidecar management, because using Istio we'll be able to create a control plane and a data planes. So I guess on the next slide, let me show. Yeah, here is, for example, we can see that using the Istio, we would be able to create a control plane here, and so that we can inject the necessary configurations into our sidecar. So we call this part as a data planes. So in fact, we deploy the sidecars just besides to our services inside of a one pod, but in a separate containers. So yeah, you might imagine it as inside of the same Kubernetes cluster. So we have a one pod here, and we have two different containers of sidecar and a business logic service. And the control plane gives us an opportunity to configure the sidecar, like by passing some environmental variables, or we can do, for example, can inject the permission sets, yeah, for doing the authorization and something like that, yeah. So, but we will mainly focus about only the data plane part, because it would be a huge topic, yeah, if we will talk about the Istio side as well. So we're gonna we will go away further from the backend development into the more darker side, yeah, to the infrastructural side of a DevOps world. So yeah, so this is why we just diminishing the scope of it and focusing only the data plane part of it, with just like having a communication between the services, yeah, using a using a containers of the services and the sidecars. So you can see here the key characteristics of a sidecar. So they can be developed and deployed just beside the service, so it's not a dependent on the service, so which is makes it pretty much flexible. So there is no any dependency of it. So in fact, the sidecars is also a language agnostic. So that means we can develop the service in any language that we want. For example, our one service can be can be developed using a Java programming language, and other one using a Python, and another with a Node.js. So the sidecar wouldn't care about that. And yeah, because this is actually truth for the microservice architecture. So in fact, you might imagine that sidecar itself, how it interacts with a service, it is like a microservice inside of a microservice itself. So like when you imagine the microservice, we have an API gateway, services, discovery service, and etc. But when we take a closer look to the service itself, so it should have a sidecar besides of each service. So the sidecar acts as an API gateway as well. So somehow like that. And we will talk about the difference between the API gateway and the sidecar proxy as well. So, and also another key characteristics of it, that it has a independent life cycle. So that means we can actually deploy it and destroy the sidecar pretty much easily. We can scale up and down. And it would, basically, most of our sidecar implementations are resource efficient. So they're not consuming pretty much big amount of data, big amount of memory. So this is why they are pretty much efficient enough. And we are having in terms of the security part, we are achieving the isolation of our service, because we are not allowing like other service to go inside to that service, even they are inside of the same infrastructure. If that service has some predefined authorization, some permission to go to call other service, so then the sidecar will gives a green light to that request to go to its service. So here is our difference between the API gateway and a sidecar proxy. So here we can see that the points about where we can see some differences of using a proxy, sidecar, and API gateway. Of course, they can be used together, because we can actually achieve a better architectural design by doing so. But mainly, like API gateways, like external API for incoming requests, like from outside of the world, So in our API gateway, we actually take care about the authentication, we might have some another service which would responsible for obtaining the tokens, for giving the tokens. So, but for the sidecars, it's like a inter-service communication. So it's mostly like a service-to-service communication. So this is mostly about checking the permissions of a particular service, whether or not it has some permission to call other service. So it is mostly like an authorization part on the sidecar level. And API gateway is a centralized in scope of the deployment, because we have only one API gateway for our whole application, for our whole microservice architecture. What about the sidecar? Sidecar is deployed alongside each microservice. In terms of the responsibility, so it is the sidecar mostly like about a low-level communication, because it happens like behind the closed doors, But API gateway is like high-level concerns. And as we mentioned already, the granularity of it is like a macroscopic view of architecture is like an API gateway, and the smaller scope, the micro level of it can be a sidecar. And in terms of the flexibility, so we can diversify client needs using a API gateway. So it's mainly for that, and we can give a fine-grained control for the sidecar, by specifying what can what kind of ingress requests and what kind of egress. So egress is like a outgoing request from the sidecar, from the service through the sidecar. We call it egress. If it's going into the sidecar, we call it ingress. So we can actually define some rules, policies to define, to control, to get some control over what kind of requests can flow over our sidecar. So this is why we have a fine-grained control over the sidecar. As a result, we're having that level of control over our services. So in our example, we will here mostly is like, this is in fact the simple service mesh architecture, how it looks like, using the Istio. So it's actually, Istio is used alongside with the Envoy, to control the behavior of Envoy, to pass some like configurations, and etc. But in our example, it's pretty much the simple one. So we have two services here, like a product service and inventory service, and our incoming requests will hit to our sidecar, but in a real world, of course, we should have a API gateway here. So the incoming request should hit the API gateway, and then API gateway should proxy that request into the sidecar, and then sidecar proxying that ingress request into the product service. So in fact, we have enabled the integration with the key cloak, which is a famous implementation of the authorization service. But only for the authentication, not authorizations, because like for the authorization, it would be like another topic for discussion. So what we're having here, we need to obtain a token, and we need to make a request with that token to the endpoint of our product service. We should hit the product sidecar, and then it should verify whether the token is valid. So if it's valid, it would allow us to go inside, and we will do some business logic. And internally, this our product service, it calls actually the inventory service. So the product service actually developed using the Python Flask. So this is just a proxy service, and the inventory service is developed by using a Java Spring. We have a in-memory database here with some records, with some predefined records, which would return the value corresponding to that request. So so the communication here would happen through the sidecar. So we're going to see that in our example just in a moment. And let's move to the coding part here. So I'm gonna show you here just code examples here of our application. For example, we have a product service which is developed by the Python Flask. For example, we are making a request to our sidecar of our inventory service. If it's not okay, we're gonna throw an exception, saying with some message here. And if it's okay, we just responding with a 200 status code. And let's see the inventory service here. So inventory service here has such an API, as you can see, with only one endpoint, which is a get endpoint. And we are retrieving the record by ID. So we have here this pretty much the basic data, with these values. So it has this properties here, and this is one just for the testing. We don't need it, in fact. I can actually delete that one. Okay, so this is pretty much of our services. And let's see our sidecars. And the sidecar for customizing our sidecar, yeah. For just writing some code, yes, for just like enabling some features. We need to specify. We need to create such called a YAML file, or we can do using a JSON files as well. So this is how it looks like. For example, let me show the Docker Compose firstly. So yeah, we are creating a Docker containers. Firstly, we need to create images of it. Yeah. So, and here is the containers of our sidecars. So this is how we need to specify that the configuration of our sidecar should have an impact, and we should see that sidecar with our configuration. So let's see the Envoy product here. So we have in fact the static resource and also dynamic resource. Yeah, in dynamic resource, so it's mostly like with a control plane. So we're not gonna focus on that. In our static resources, in fact, it's not a requirement to specify. As you can see, let me make it a bit bigger in terms of the size. And yeah, we need to specify the listeners. So listeners is would be a URL address of our sidecar. Yeah, we need to specify the port. So like exposing the port for the incoming traffic. And then we are specifying the filter chains. So then we are saying that we want to use a connection manager filter. So this is responsible for the HTTP connection. So it's saying that ingress HTTP. So, and then based on these routes, so we're having a like enabled for all domains, yeah, but we can actually specify our like domain as we want, yeah, because in order to avoid a cross origin request surgery, if I'm not mistaken, to avoid that error, so we're just specifying that sign here, yeah. So, and we are specifying here some prefixes, like for example, if we have seeing such prefix, we should define the incoming request to this cluster, otherwise to that cluster. So this is how we specify our filters. And we having another HTTP filters as well. Inside of the HTTP filters, we can write our own customized version of filters as well. Yeah. So as I already mentioned, that the native language that is used for writing the Envoy is Lua and C++ mainly. And that's why we need. It's better to use a Lua programming language. Yeah. So, in fact, here we are specifying an inline code here like that. Yeah. And we need to like import that configuration and call that Envoy on request function. Yeah, with a request handle param here, and call the main function inside of our inside of this package. So you can see that here we have a logging.lua file, which is responsible for logging purposes. So we actually have created here just simple filter using a Lua, which is responsible for like logging some requests. Of course, we can do that by using some predefined filters, but for the sake of the example, how we can write our own custom filters. So I created this file here. So this is how we specify it inside of the function on Envoy request here. And we also can write a function Envoy on response, yeah, but it would be like a kind of post request logic, yeah. So, but we don't need that one right now because we are focusing right now is just like to see that what kind of requests are coming into our sidecar. And here, another example of our filter that JWT auth n, so which gives us an opportunity to authenticate our request, yeah. So we are specifying the issuer of the token, yeah, and parsing the token here, and yeah, like forwarding the token and specifying the URI to the cluster, like specifying the timeout time for how many times it should try to establish the connection. And we're also caching the token value here inside of a sidecar, so we can use that. We can actually use that sidecar for the caching purposes as well. So, but it gives us for the authentication, yeah, like ability for the authentication. If I'm not mistaken, we can use a authorization filter of a sidecar, but it would take a bit longer, yeah, because I actually tried to do that and I thought I came with a conclusion that it would take a long time. So yeah, and I decided to stick with a more simpler approach with using a just authentication on the sidecar level. So and also for the authentication, we need to specify the rules that every prefix, yeah, so every route should be checked for having the token, yeah, in our request. So no request should pass without a token here. So at the end, we need to specify that with a router filter here. And yeah, I already mentioned about a clusters. Yeah, as you can see that we have a product service cluster, the sidecar inventory cluster, and the key clock cluster. So our sidecar is like a one service, yeah, and it should know that where should it send the request. So we should specify the clusters. Yeah, inside of a cluster, we can actually write one or more than a one service. Yeah, we can specify it. We can actually group some more than a one service into a one cluster and specify some logic there. Yeah, in what kind of way the request will be go to the particular service. So in our example, we're just having a one service behind our sidecar because yeah, it's better to have only a one sidecar, one service behind every sidecar, yeah, because it is like a helper for our service. So we're having a product service here, and we are specifying that address of a product service, which is the address of our Docker container with this port. And yeah, we're specifying the endpoints, giving the name. We can actually, of course, give some random name, but it's better to stick with some meaningful names. We're specifying the connection timeout and load balancing policy. Usually is a round robin. And we can write, actually, you can see that write the name of our types and policies. Yeah, so it doesn't matter. It can be either in an uppercase or lowercase. So it doesn't matter for our Envoy configuration. So it would understand that anyway. So here we can see that it's pretty much the same for the key clock here. the same type of load balancing policy. We can actually configure some load balancing policies for our sidecar, customize it. And in fact, it actually acts as a reverse proxy as well. So yeah, so we might have a different instances, so several instances of the same service. So depending on the requests, we can actually specify, we can actually send those requests into the different instances of the same service. So yeah, we can do that because Envoy gives us such opportunity to do so, because we can configure that load balancing policies here. And we of course need to specify the sidecar as a cluster as well, because we are making a sidecar to sidecar communication. So incoming requests. So in fact, like as we saw in our example, like in our schema, let me show it one more time. Yeah, so like incoming is like a ingress coming into our sidecar product, yeah, and going out from the product and coming inside of, in fact, when the request has went through the sidecar, it's called already an egress request, yeah. So this is again like we had some logic here, some executions here, and the request is going inside of our sidecar one more time. So this is again a ingress for our sidecar. Then it is like going through it and just proxying towards that cluster, which we have specified here as a sidecar inventory. And this is why we have specified here just a one stat prefix, yeah, in our HTTP connection manager as an ingress HTTP. So there was no need for us to create an egress HTTP as well, because if we wanted to do that, in fact, we have to create two separate listeners, yeah. But in our examples, it's not needed. Okay, and also it has a admin endpoint, like we can specify the access logs, yeah, and to see some metrics, to see some data about our sidecar, yeah, about its upstream. So in fact, we also may call it like ingress request, yeah, like a downstream request when the request going to the to our service, because it is like place it behind the sidecar. So this is why we call it like a downstream, and the upstream when the requests are going from the service and passing through the sidecar, it is like a upstream request, yeah. So it's like a going out from our sidecar. So yeah, this is another definition here. So we can see that we have a such a one downstream cluster, and in fact this one is a upstream cluster, because we are going from our Envoy product sidecar to the sidecar inventory. And key clock is as well, yeah, we can consider it as an upstream, because we are making a request from our sidecar towards the key clock. Okay, and let me show you the Envoy inventory as well. So it's pretty much the same configuration here, but we have specified the different port here. But just for the visibility purposes, we can have the same ports here. Like we can in fact specify the URL addresses of our sidecar as a discovery information in our API gateway. So yeah, it should be used in cooperation, so in order to create a better architecture. So in fact, this is one is pretty much the simpler, because we are just like forwarding the proxying the request to our inventory service. So again, we are using our custom filter for logging the request. So log request function. So you can see that it is a log request function. And we have the clusters in inventory service and the key clock, but in fact we are not using a key clock here because you might see that we are not forwarding the token, because we are not forwarding the token to our upstream request. Yeah, so this is why we haven't used the key clock cluster here. We can actually remove that, or we can add that one as well. So I had in mind that to add the authorization part of it, but then I decided to stick with that authentication part. So like this, in order to have a much clearer view, let's remove it. Okay. In fact, I just forgot to mention about the Docker file that we have here. So the Docker file is pretty much the simple one. We just need to specify the base image of Envoy proxy that we wanted to use and copy our custom files into our ATC Envoy file into that directory, that file logging.lua file into that directory, and we are calling that like importing that and calling that function like that. And then we're just like executing the command to start our sidecar. So this is pretty much it from the explanation part. And let's see how the requests are being traced, how requests are being flown between the services. So let's see that. So here we have let me check a Docker here. In fact, we have a up and running services. We have a key clock inventory service, which is indeed a Spring application. So it is initialized already. And we have our records have been imported as well. And key clock. And we have a product service here. And our Envoy proxy sidecars. So in fact, Envoy is doing the job of the Nginx service, Nginx server as well, because it is like a proxy server. Because Nginx as well is been like a Lua programming language is used to develop to develop the Nginx service, but Nginx is like a if I'm not mistaken, but it doesn't gives us such more flexibility as Envoy gives us, in terms of the authentication, authorization. But maybe we can do some custom like authentication, authorization. But mostly it's like use it for the load balancing and like for logging some requests. Because and also what gives us like Envoy in terms of the logging, we can actually measure the UCT, upstream connection time, UHT, upstream header time, and such headers related to the timing of how efficient is our request can be shown with those request headers. So we can see them in our product, in our Envoy proxy sidecars as well. But yeah, I haven't enabled that debug mode because it would be too much like info about that. So yeah. And also you might ask why we need how it's happening, like service to service authorization. So in fact, we can create when we have an authorization service, so in fact, every service that we have should have its own client ID inside of a key cloak, So it should be like based on the multi-tenancy, So it should be like a multi-tenancy. It's like having a multiple realms, So to have a isolation between the different vendors, depending on whom we are developing the product, because the same application, the same architecture, but with different database informations, with different database records inside of our DB. So in order not to have the fixed them, we just need to have a multi-tenant environment, So Keycloaks gives us such an ability, having the multiple wheels. So inside of a wheel, we can create a couple of clients. So in fact, for each service, you need to have a separate client ID, with a client secret. So we can enable the client-to-client authorization, which is like a client credentials flow, So, but in our example, I'm just receiving a token as a admin user, but it would be better to have using the client to client credentials flow, So it would be like that, product service would get that. Would get its token, But in fact, the request, already user should have that token, and the sidecar just checks that one, And or just or it can make a request, because incoming token can be become a huge, because it shouldn't kept all the permission inside of it, So user shouldn't know that, because it would lead to the higher latency as well. So that's why we need to have a lower amount of information in our a token, which is coming from outside world, but internally. So we can enable that inside of a sidecar. So to call the key cloak and use a client credentials flow, obtain a token, and when one service, after finishing some job, after finishing some operation, wants to call the other service, it should pass through the sidecar by getting that token, and that sidecar should check that whether or not that service has some predefined permission, to make those calls to this service. So let's see an example here. So I'm having a key cloak here, let's obtain a URL, the token, and let's make a request. So we are getting let's try to get another information, So we are getting we don't have a record for the 3. So it's showing us an error. So yeah, it can be done better, but it is what it is right now. So let's see the logs here. For example, let me open up the sidecar product container. So we can see that our custom log has been called up. Yeah, so having like seeing that get and pass, like method get and the pass of it like a products, and we don't not passing any headers here. So in fact, token should not be visible, yeah, as we all know, on the logs as well. And yeah, let's try to check a inventory. Yep, indeed. So we can see that this product, we are calling the product service here. So we can see the like logs here of the product, yeah. So it shows the 500 error, like if it's not found, yeah. Of course, I should have done like 404, but yeah, right now it doesn't matter. So yeah, we can see that we are making a request to the product service, but firstly, it is like going through the sidecar product, yeah. Let me see the URL, which is a localhost 8082, which we can see. Which we can see here, like, yep, indeed, we do have such ports for our sidecar product. Just like, let me exit the full screen, yeah, in order to avoid to go back and forth. In fact, I can right now close the window. And yeah, so we are like hitting the product sidecar, and it calls in my time, I guess we can see that as well. It calls the product service, and the product service calls the sidecar of inventory. Yeah, so we can see that the log clearly shows that such endpoint has been called up. As a result, our inventory service also shows an exception that inventory not found. Yeah, so if no record is being found, so there is no record, like when we like make some successful requests, it's not printing anything like that. So yeah, in fact, our sidecar can do the logging for our application. Yes. So, and yes, for example, let me like try to use a invalid token and see what might happen. Or might be the token is already expired. Yeah, so JVT is expired, we can see. And let's see that did our like request, no, it hasn't reached the product service. So, but it actually shows that because, yeah, because order of it like matters, yeah, because I place it the logging functionality on top of the JWT, yeah, on top of the authentication. So it is, so here order matters. So from up to down. So the first filter will be invoked in a first order. So, and let me like, for example, try to like remove one element, and let's try to yeah, we can see that the header is invalid. Maybe let's try to see the key clock. Yeah. So it's not showing some some information that we need here. Okay, and let's move back to our presentation. Oops. So let me find that one. Yep. Okay. So we can see that that was our example of our simple service mesh architecture, like a sidecar to sidecar communication, service to service communication using sidecars. So what kind of benefits and trade-offs it can gives us? So on the first hand, it gives us like a simplified approach for developing the microservice, because we don't need to like add some logic for the authorization, logging, and etc. inside of our microservice. We're having a better observability, monitoring, and also having a better scalability and resilience because we can scale up and down those instances, and we can choose the load balancing strategies. But the drawbacks of it, using the sidecars, it also creates a additional resource overhead, because anyway, regardless that they are lightweight, but of course they are like consuming some memory space. And also in addition to this, we're having a potential danger of having a single point of failure. So when like sidecar, what might happen when our sidecar became say unreachable? So then like so we can do nothing. Like we can actually, in fact, we can actually create a couple of more sidecars. We can define that one as well. But anyway, it would be like not a nice architecture, because and we can create a control plane to avoid having a single point of failure, but anyway, like using the API gateway, it has a single point of failure possibility, such a danger of possibility as well. And of course, additional latency, because again, we are adding another like a lightweight service between our services. In fact, so it is need to go through our sidecar, not go directly to our service. So in addition to this, it's actually adds some couple of milliseconds on top of it. So this is why it has some like, even it's a small, but adds some a little bit of latency. And of course, it might sounds a bit silly. Somehow we're having a simplified configuration of microservice, but overall the architecture becomes complex. So if it's like we have a couple of more sidecars, so it would be like we need to implement that the control plane to control the sidecars. So we need to like customize them, and that would be difficult to do so. So and also I forgot to mention that about dynamic service discovery. So inside of a load balancing part, we can do see that it's actually like depicts that by the name of it, by the name of the service. Just finds out the service by its name. So we're having a like discovery service. We can use it as a discovery service as well. And load balancing, as we saw, TLS termination. When we're having a certificates, over a HTTPS network. So it gives us such an opportunity to do so. We can add a like additional filter for that purpose. To do that TLS termination, and it actually supports both gRPC and HTTP2 proxies, but also it has a it has a router for the Kafka and Kafka, if I'm not mistaken, for the RabbitMQ, but I'm not sure about the RabbitMQ. But for the Kafka, it does have a such a router to use it. Yeah, but it is mostly like having a REST calls between the services. So as we saw that it has a circuit breaker pattern. Yeah, it checks that it might check like whether or not the service is healthy, yeah, and send the request to the healthy instance of it. Yeah. So we can have a percentage traffic split, yeah, staged rollout. So it is like a choosing like which percentage of incoming requests would go to the particular instance of it, yeah. So it is like a canary testing, something like that. We can do that, and fault injection, yeah, we can do some like that as well. And of course, we're having a rich metrics. And of course, I just forgot to show you guys like, oops, we're having a recursion here. Envoy admin, yeah. Here's how it looks like. The Envoy admin panel, yeah. So it is like, doesn't look that beautiful, but it is what it is. So it is for the inventory service, yeah, as you can see. So it's a sidecar for the inventory service. Have some metrics. We can see the heap dump, yeah, like listeners, some information about it. And the same like for our second sidecar. Yeah. You can see the information about that. So it is for the inventory. Another one, I guess, was for the proxy, yeah, product. Because here we have one. Yeah, here we have a inventory service, key clock cluster, and what else? Yeah, inventory service. And yes, this is how it looks like. We can see some information about them. We can enable the Prometheus as well. Okay, and yep, I guess let's move back to our slide. I guess we can move Q&A session.
First of all, thank you very much for such a great talk. That was really a pleasure to having you, and thank you for starting day number 3 of Java conference. We do have a couple minutes for talk, so I pass the voice to Alexander to ask them.
Yeah, thank you, Roman. Thank you very much for Javokhir. I know for sure how hard it is to be the first on such a famous conference. So kudos to you. And we have many questions in the chat. Let me ask just a few of them. We don't have enough time. We have a question, and it's mostly about why should we consider using Envoy proxy? Because first of all, it introduces additional complexity. It's necessary to write code in Lua, but why should we consider using it instead of, for example, something like a Spring Cloud Gateway?
Okay, this is a nice question, actually. Yeah, in fact, the Spring Cloud Gateway is an implementation of API Gateway. Yeah, but Envoy, it is for the sidecar. It is like a micro level of our. Or it is not the same as the API gateway, yeah. So it is just like stays alongside of our service. So we can use the different implementations as we saw here. So it shouldn't be the Envoy, but in order to avoid writing some cumbersome code by ourselves, yeah. So we it's sometimes it depends on the business needs, yeah. So you can use the Envoy if you have some like requirements, yeah, like for having a lightweight application. So yeah, like a faster like a deployment, faster, like a creation of the sidecars, so and etc. But we can actually create our application on our own, like using for example, Quarkus, Quarkus framework. We can actually write our sidecar from scratch because it is also a reactive, lightweight, like a subatomic, as we heard that like framework, which creates a lightweight application, but it would be will take a bit longer development time than like implementing it using the Envoy proxy. But Envoy is much simpler way of having the sidecars.
Good. Thank you very much, Javokhir, for answering the question. I have a follow-up question really on the same topic. So as you mentioned, we have modern frameworks like Java, like Spring, Quarkus, Micronaut, anything else, and majority of them have, let's say, modules which allow us to put some cross-cutting functionality on top of our services, like a Spring Boot starters, for example. You add a dependency and you get a cool functionality out of the box. So the question is, when should I consider start using the Envoy or any other, for example, sidecar, instead of building in or plugging in these capabilities into my application? From which point I should start using it?
So mostly like when it comes to authorization part, so when there is a concerns, like for example, you're having a third-party libraries, so, and you need to achieve that the project that you're working on, so like it is like the private project, so it's not accessible, so it is like a microservice. So because of the security concerns, so every module should have its own authorization, so when the module-to-module communication happens, so it shouldn't be like just one module calls another module, and the request should go without any authorization. So in that case, so it comes handy to use sidecars because of the authorization purposes, because like we define the permission like for our service, for our each service in our microservice architecture. We can actually define the permission for our each endpoint. For example, it can be like in our example like inventory ID, so it can be like get inventory ID, or like a post inventory, so it can be just a name of the permission, and we can group that into the one policy, for example, create policy, like a get policy, and read policy, write policy, and something like that, as like in the AWS. And inside of that sidecar, we can cache those policies, those permissions, and when the other service calls, when the call happens between the services, so the requests are being intercepted by the sidecar, and it checks that whether that request, that calling service has actually the predefined permissions to call that service. So because of that service-to-service authorization, so this is why we need to enable like client credentials flow on the key clock side, and like persisting the token, like not a token itself, but we can actually like cache it for some minute, like in order to avoid like checking every time and going back and forth like between key clock and the sidecar. So for that purpose, mainly for the authorization purpose, not authentication, but for the authorization purposes, we are using the sidecars, and replace and like some architectures like using a Nginx besides the modules, so, and also to avoid using the Nginx, because sidecars tend to be much lighter than the Nginx services itself. So this is why.
Yep, good. Thank you very much for answering the question. Now it's crystal clear when we should consider using the Envoy proxy. And again, thank you very much for such a fantastic talk and kick off the day. Good, thank you.
Thank you very much. See you on the conference. Bye-bye.
Bye-bye, guys. Thank you so much.
We're back. So tough schedule. So we have to move to our next speaker. But before we do it, just short reminder, guys. We have offline activities. Really last chance to take part in them. We will close them very soon to have time to consider winners, and also subscribe to our social networks. They are here here above me. So yeah, let me introduce and invite to our virtual studio our next speaker. It's Gunnar Letsko. Gunnar, hello.
Hello, guys. Nice to meet you. Awesome conference. Honestly speaking, we on Wednesday, on the first day, we had in Georgia co-watching, and it was fantastic. It gathered different guys, and we were in Batumi, and even some people from we were in Tbilisi, but some people from Batumi came to us to see it.
Wow, wonderful. Great to hear that Javon helps people finally getting offline. That sounds
Yeah.
great. So, yeah, we don't have a lot of time, so let me ask you to share your screen and we'll dive right into your talk. I will just remind everyone that we have 2 chats on YouTube and on the platform, so please write your questions, write your reactions, your comments, what you think about the talks, your maybe additions to what speaker are talking about. We reading everything and we will try our best to ask you questions. Yeah, Gunnar, good luck. Let's go.
Yeah. Hello, dear colleagues, and welcome to Tech Talk dedicated to Micronaut. First of all, thank you for your making time to attend this presentation. Before we start, let's get acquainted. My name is Hunar. One more time, I almost 10 years in IT. I'm engineer and manager and participated in different projects on different roles, starting from junior developer to solution architect. As you already heard, I'm from Georgia, I'm from Tbilisi, and here I'm a part of our local Java community, Georgia. And I arrange a lot of tech talks, and I hope some of you already attend some of them. So before we start and go to our agenda, I hope some of you haven't heard about Micronaut, and for these people, I guarantee that at the end of this TikTok, you will have a basic understanding what is it Micronaut is, how to Micronaut to use, and what is the main difference between Micronaut and Spring Boot. And for these guys who already has an experience, I hope you find something interesting also. So what we're going to consider here, as I mentioned, we will work through some general concepts of Micronaut. Then I will dive into details how Micronaut creates bean application context. Then I will sum up this with the live prod example and compare it with the most famous competitor of Micronaut and Spring Boot, Quarkus. So let's move on. Let's go through the history of web application creation. And firstly, we start with pure servlets. Then we have EGB. Then Spring came to us and save us, bring us this flexibility. After that, we have and Spring Boot that's bring us executable jar, dependency consistency, and other useful features. And nowadays, we have different choices. We can choose Spring Boot, Quarkus, Micronaut, and there are dozen maybe other vendors, framework that we can use instead of Spring Boot to build some web application. I hope everyone is aware about how Spring Boot works, because during the whole presentation, I will refer the key features to Spring Boot and compare it. So what Micronaut is, as I mentioned, Micronaut is a framework that provides the same capability that Spring Boot has. It also provides executable jar and so on and so forth. And you can build your web service based on this. Micronaut has 2 different type how you can build your run your application. You can use command line interface to start it, or you can use web interface. On this slide, you can see the main basic commands that you can use to build your application. Micronaut has been created in 2018, yes, by guys who created Grails, and they were inspired by Spring Boot, but they also want something to improve. And the main languages that Micronaut uses is Java, Groovy, Kotlin out of the box. But if you want to write your code in Scala, it's also possible, but with help of additional plugin. As I previously mentioned that Micronaut has been developed in 2018, this is a time of microservices, time of clouds, and Micronaut is designed to build microservices. So it out of the box support these microservice patterns like a retry mechanism, load balancing, discovery service, circuit breaker. And on the second side, it supports serverless functions. It supports Kubernetes, native images. So it builds to cloud and to microservices. If we're talking about microservice architecture, we always put in mind that we need to use some messaging system. And out of the box, it supports the most popular cloud agnostic messaging system like Apache Kafka, RabbitMQ, ActiveMQ. If we're talking about clouds, it also supports SQS, SNS, PubSub. It depends on which cloud are you using, so you can, without any problem, use messaging system. Another important aspect when you are working with microservice system is security. And out of the box, Micronaut supports built-in endpoint, working with GVT tokens, session authentication, security events, and so forth. For more details, you can look at this slide and see what you can really use out of the box. For other stuff, there are some libraries that you can use and customize it. When we're talking about management and monitoring, so Micronaut also provides some built-in endpoint that you can use like Actuator in Spring Boot, or you can customize this built-in endpoint. For example, health check, create your own health check and customize it in application YAML. And yes, you are right, you're correctly heard, application YAML. So there are no so many differences between Micronaut and Spring Boot, and configuration is also stored in application YAML file. Let's dive a little bit deeper. And the cornerstone of application context in Micronaut is also bean. Beans has different scopes, and on this table you can see the scope. Let's go one by one and consider. Some of them are absolutely the same like in Spring Boot, and some of them are absolutely different, and some of them are new. So singleton, absolutely the same, one bean, nothing special. Context scope is like the singleton, but it create at the same time as application context is created. So it is eager initialization. Other bean scopes, almost all are initialized lazily, and we will consider it a little bit lately on the our live. So infrastructure beans. Infrastructure beans are the beans that can be overridden. So Micronaut provide this functionality to override beans. And for this, you can use annotation replace. But infrastructural bean can't be overridden, and they will fail on startup time. Prototype. Prototype is absolutely the same like in Spring Boot. You can create as much instance as you need of this bean. Move on, thread local. Thread local is, if you are familiar with thread local type in Java, you will understand the scope of this bean. It creates each bean for each thread. Refreshable. Refreshable is for me, it's most interesting one, and I want to stop here. Refreshable scope is a custom scope that can store some like caching data and be refreshed by refreshing point. But what I want to emphasize here, that refreshing point is built-in endpoint that by default is disabled. And if you want to have this ability, you should customize this endpoint in your application YAML file. And request scope. Request scope is absolutely the same like in Spring Boot. So for each request you create, for your bean is created. Let's move on. One of the most interesting and useful thing in Spring Boot is starters and conditional beans. Micronaut also supports such kind of functionality and support the different and wide range of these conditions. But what is the difference? The difference is in annotation. So conditional beans, if you want to create conditional beans, you place annotation on your class level with requires annotation, and in parentheses put the condition. It can be presence or absence class in class path. It can be environment, or in Spring it names profile. It can be properties, environment variables, and so on and so forth. So wide range of different conditions, and for more details you can go to the documentation and find all of them. And here we come to the differences, and these creators of Micronaut name it as advantages over Spring. The main point that application context, all bean definitions, and other helper stuff in Spring is created on runtime and with help of reflection. It consumes memory, and it slows down the startup time of your service. And that's where Micronaut creators find it inconvenient and try to improve it. So they move the creation of bean definition from runtime to compile time. And they strive to not just use reflection, but avoid of using reflection and use introspection instead of it, because that's how we can save memory consumption and decrease it, save our memory. Let's take a look at the code briefly. For example, this is our service. And let's go to the classes and see what is generated. For this publication service, we have bean definition that has been constructed. And we have bean definition reference that tell us what is the type of bean is created, what is the type of bean definition, some metadata, and what is this bean? Is it primary? Is it context? Is it conditional? Is it singleton? And so on and so forth. So this is the main advantage, but we will see a little bit more generated code a little bit later. Micronaut also supports different types of tests. So it supports Makita and JUnit test, and it has its own integration test framework, like Spring Boot integration tests, right? You can use an extension for JUnit 5, Spock, or COD test. It starts automatically service. You can replace your beans, mock them, and work with tests. For this project, also is written some tests, and let's take a look at this test. So first of all, if you want to write a test for your service, you should put annotation Micronaut test. Then, if we switch to our service, we have only one dependency. This is our repository and several methods. Here we have this dependency. We inject it and inject our service that we want to test. But we can not mock it, but we can mock it if we want to simulate some behavior. And to mock it, Micronaut also provide this annotation, mock bean, and you should implement some method and use mock static mock method of Makita. If we look at the test, there is no difference between Makita test or Micronaut test. So it's as simple as it is. If, for example, we look at the controller tests, for example, we have controller. In controller, we have some method and service. And let's firstly look at the controller code. It's too easy. Put annotation controller. We have one dependency, injection with help of constructor, and one method. Here we inject this service. We inject HTTP client. This is Micronaut HTTP client. And also we are mocking the service, for example, and we make some request. We block it because HTTP client is written in reactive mode nature. And then we can get response status, response body, and validate it, and so on and so forth. So that's it if we're talking about tests. So, and in conclusion with test, let's run it and see that this is working. It will take for a while, I think. But as you can see, it is pretty straightforward, nothing special, and it is similar to Spring Boot tests. So yeah, my computer decided to make some surprises. Okay, I will left it and we'll come back to this and move on. So now live example. First of all, I want to start our journey from the build Gradle. How Micronaut generate this code. It's created by annotation processor, so nothing special. And you can see test is finished, successfully passed. So nothing special. Let's come back to our annotation processors. You can see many annotation processors. Why? Because Micronaut positioned themselves as a lightweight framework. So if you need something, you should enable it to have lightweight service. For example, let's go through one by one of this annotation processor. This annotation processor is for Swagger. This is for validation. This is for data GPA. like Spring Data GPA, Micronaut has its own implementation. This is for injection, bean injection, and this is for HTTP validation. And we can customize our Micronaut application in this section. This tells us that Micronaut uses NATI as a service. It uses GUnit 5 for test and put some package for annotation scanning. We can customize to run it on Tomcat, but if we add a Tomcat, we need to add additional dependency to have a dispatcher, because by default it uses NATI under the hood. Let's come back to the controller layer. Controller is look pretty similar like in Spring Boot. So you just put controller annotation with URL mapping. And for each method, you will specify get, post, put, patch, delete, and so on and so forth. Let's go to bytecode to see what is generated for controllers. What code is generated for controller? For example, publication controller. Also bin definition, reference, and that's pretty it. If we want to have some more specific logic and we want to have some validation, for example, we have validation, custom validation. We mark this controller as validated, and this is Micronaut, also annotation, and put some custom validation for our model. And what I want to emphasize here that we must have this model introspected, marked with introspected annotation, because our validation will not work if we omit this. Micronaut should know about our model and can access their fields. If we look at the bytecode, you can see that this is introspection created for this bean, for this class, and reference to have an ability to use it. If we look at the controller, for example, image controller, we have intercepted. So Micronaut create a proxy and use this proxy for this controller. So after controller, we are going to service. For example, publication service. As I previously mentioned, put just singleton or context and other bean scope annotation, and Micronaut will know that the bean should be created. But if we have some additional logic, and for example, we have some transactional methods, Micronaut will create also proxy, and let me share. Intercepted, and for this method with annotation transactions, it will create a proxy. So this is how we can see that how transactional our work is working. Pretty interesting. So if let's move on to repository level. Repository level is the same, absolutely the same like Spring Boot Data GPA. We put repository annotation, and in repository I put the name of the data source. Why? Because for this service I have two data sources. As you can see here, name of the data source and some configuration. And the first must be default. This is a rule of Micronaut. And the name of the method, like in Spring Data GPA, find all order by name. So it's pretty clear. There is no difference. If we let's before move to the entity layer, I will show what Micronaut generates as for repository, also bin definition, and exact, that it show how it dispatch the action that comes to us, and bin definition reference with information of what bin should be created, right? And by default, repository annotation is also singleton. And entity layer. Entity layer, absolutely the same annotation, are the same JavaX annotation, so no difference. What I want to show you that all entities are introspected, and introspection for each entity is created with information about fields. Let's come to the bin validation. For bin validation, I created my custom annotation, and for custom annotation should be created some validators. And here is another way how to create a bin. This is a factory class. Factory class is like absolutely the same analog of configuration class in Spring. So you can create, and here I deliberately create validators with help of this factory class to show this ability to have a different type of creations. And if we want to take a look at the code that generated, you can see that sort order validator 1, validator 2, reference, and bin definition is also created for this. Absolutely the same. Okay. One more thing that I want to mention is the configuration properties. Micronaut also supports like Spring Boot configuration properties, where you can put the prefix of your configuration. And in application YAML, it will analyze it and find that at this prefix we have these properties. And if we look at application YAML, we also can configure Micronaut, configure course, port, Swagger configuration, flyway integration, and so on and so forth. And if you take a look at the name, we have different environments, like you can specify as much as you want. And what I want to mention, the last but not least thing that is also important and interesting, is error handling. If you need to handle your exception, you need to implement exception handler, where first parameter is the type of the exception and the second one is the response type, and implement handle method. Here is important to put produce annotation. That annotation tell us that we produce some object outside. Without this annotation, it will not work. And as you can see, it is for each type you should create each implementation. That's pretty it. What I want to show you more is how does it work. So as I mentioned previously when we discussed bean scopes, that by default initialization of beans are lazy. So if we command this annotation and run the application, application will run safely without any problem. Let's see. Wait a minute, please. Something with my Windows. Yeah, it built the service and start the application. It will not take long, like 7 seconds or something like that. Oh, today, before this, it was 7 seconds, but okay, no problem. And if we make some request for this publication, we will see the error, 500 error, because our bean initialized lazily. But if we, for example, for publication service, change the bean scope to context, that tells us that it should be initialized eagerly, we will see it on the run of our application when we start. It will also take a while. Yeah, it's look like my computer want to a little bit joke about me. Before this talk, it was fast, but okay, no problem. We will wait. We have a plenty time. Yeah, as you can see. And let's fix everything and see that this service is working. By the way, this is a real service that is working on production on my previous customer. That's why I'm not showing a lot of complex logic. And this is a service is working 1 year without any bugs, and I'm happy that it is working. And it's worked fast. Just my laptop decided to make some jokes in front of all of you. So let's fetch. Yeah, everything is working perfectly. Let's talk about drawbacks of Micronaut. As I mentioned, and it is obvious that if we move creation of bean initialization, some bean definition generation, and other helper stuff from runtime to compile time, we have longer compile time, right? And bigger size. Comparing to Quarkus and Spring Boot, Micronaut has small community. And as I show you, not convenient error handling. You can create implementation for each type of exception. Obviously, we can create a factory class like configuration and put everything here. Yes, it is, but for me, controller advice from Spring Boot is more convenient. And yeah, one thing more came to my mind, that Micronaut testing framework that create this integrational test, it built the whole application context and run the whole application. So if you have some integrations like with the database or Kafka or Redis, you should use some test containers. And according to documentation, and I haven't found any information that you can somehow disable some of the functionality. So this is also like a drawback. Let's go to comparison with Quarkus. I deliberately not compare about performance and memory consumptions. Why? Because it depends on the service side. For example, bean validation in Micronaut uses introspection. In Quarkus, it uses reflection. And if we are using Quarkus small services, it works faster and less memory consumption use. But when our service become bigger and bigger and have more and more logic inside it and validation logic, for example, this reflection will eat memory, and where Micronaut can win and will win for memory consumption 100%. And if compare other stuff, we can see that Micronaut a little bit older guy. And about supporting languages, in Quarkus we have Java, Scala, Kotlin. In Micronaut we have out-of-the-box Java, Groovy, Kotlin, but Scala is also possible, as I mentioned previously, that with help of additional plugins. In bootstrap phases, I emphasize that Micronaut has compilation time, where it is generated this code, and runtime, where it gather all bin definition and construct bin tree. In Quarkus, we have a little bit different. We have augmentation phase, where code optimization, bytecode optimization, and so forth. And then we have static initialization and runtime initialization. Tests against native image. Why I deliberately put it here? Because in 2021, Micronaut doesn't have this ability, but Quarkus has. And now, thanks to this competition, Micronaut has this ability. Micronaut didn't have a web initializer, and now it has. So this competition bring us only advantages that we can consume as developers. You can find on the screen useful links that you can use. Documentation for Micronaut is great, really great. So you can find everything that you need. And I think this brings us to the end of the presentation. And that's it from my side. And I would be glad to answer to all your questions.
First of all, thank you very, very much for such a great presentation. I do feel that now we all know more about Micronaut and all we'll consider of bringing it to our project. So we do have questions, and we do have a lot. So passing the voice to Alexander for asking them.
Yeah, so thank you very much, Roman, and thank you very much, Hunar, for your fantastic talk. I was really interested in, well, I'm keeping an eye on frameworks like Quarkus and Micronaut all the time, and we have definitely a number of questions. Let's start with the simplest one. So in Spring, we can use Lombok because it's super convenient. It's really easy to use it because, you know, the code executed after it is compiled, and Lombok does a lot of code generation. But right now in the Micronaut, we should somehow integrate code generation from Lombok and code generation from the Micronaut itself. So how smoothly does it work together?
Actually, what Lombok did, it used annotation processor to generate code, right? And after this code is generated, Spring use this code. There is an integration with Lombok and Micronaut, and there is no problems, so you can use it. On our project, we decided to not use Lombok because we also have generated code, and but there is this is not a tricky question, and it works fine. So don't worry.
Okay, great. Thank you very much. Another question from our audience is also related to syntactic sugar and developers, let's say, performance. So another question is about smooth integration with Kotlin. You mentioned that Micronaut works smoothly with Kotlin. However, the question is, does it support, let's say, good features like null safety like Spring does, especially in scenarios when we need to integrate code written in Java with code written in Kotlin?
Honestly, I haven't tried to write this service in Kotlin, but I saw some examples of the service that is written in Kotlin, and it was working. I don't think that it should be any problem because it's two Java-related JVM languages, and guys who created Micronaut, I think they also consider it and kept it in mind.
Okay, great. Thank you very much for answering. Well, you know, Spring Boot 3 wasn't released really recently, but it was released, let's say, this year. Well, not really far, not really a lot of time ago, and it brings a lot of fantastic features to us. For example, it allows us to build a declarative REST client and choose implementation, underlying implementation. Almost on the fly. So the question from our audience is, which HTTP client does Micronaut use by default? Is it possible to switch it on the fly or during the configuration or somehow?
Micronaut by default uses reactive HTTP client, and it is working based on NATI, and you can write even your code in reactive mode. And as it is not based on servlet, and if you need to run your application on Topcat, you should add additional dependency, Micronaut servlet dispatcher, something like that. And after that, it will adaptate its infrastructure to servlet dispatcher. But under the hood and natively it is reactive. And if we, for example, want to implement some server sent event, it is only can be implemented in reactive way in Micronaut. So a lot of stuff is done in Micronaut under the hood in reactive way.
Yeah, great, great. Thank you very much for answering. And in this case, I have another question also from our audience. So, because Micronaut does a lot of code generation, it might be hard to debug it. What's your experience in debugging the Micronaut applications?
It generates only some stuff that is used to create application context. The same stuff Spring Boot generates on runtime, and it is not easy to debug even in Spring Boot, but this is some internals, and if it is failed to start, it tells you where it failed to start. And as I previously showed, when I commented repository, we have this information, error message that repository is absent. So well descriptive, and they created nice core, really nice core. Micronaut core is gives you detailed and clear error messages. Uh,
Mhm.
I know that not such a big community, and Stack Overflow is not filled with all answers, but one more time, clear messages and documentation help you to handle a lot of stuff.
Yeah, thank you very much for answering. Well, a really similar question regarding developer experience. So in Spring Boot, I'm a big fan of Spring Boot DevTools because it significantly streamline and boost your developer experience. Do we have anything like that in the Micronaut?
Uh, Quite interesting question. You know
I
that
hear.
you know that in Quarkus has its own plugin that make your life easy. For example, if you have ultimate IntelliJ idea, yes, you can alleviate your life. It can alleviate your life, but for community edition, you should do a lot of stuff by yourself. Yes, this is a pain point, but only hardcore, only challenges.
Yeah, definitely, definitely. And I'm asked most of the question from the Spring guy perspective because I've been using Spring for long. I see a lot of applications are built on top of it. So that's another important question again for the person who may consider moving from Spring to Micronaut. In Spring we have a killer feature. It's a Spring Boot starter. You just add a dependency and it works out of the box. Do we have anything like that in Micronaut? And how hard is to write your own Micronaut starter? Let's call it like this.
uh, you know that to add new dependency, I showed annotation processor one by one, which annotation processor is looking for what annotation and build definition. If to add a new feature, it's not hard. You just add a new dependency, and if this dependency has something under the code, for example, if it is like killer feature like GPA or messaging or
Mhm.
Swagger, you should have this annotation processor. If you need to do something special, I think you need to create some annotation processor, or you should create deliberately bin definition. What
Okay.
I like in Micronaut, for example, how to and why we chose this on our project, because it takes me one day to rewrite my Micronaut application into Spring Boot application. Only just rewrite annotations, imports, and build Gradle, and the same for in the vice versa, so it works.
Mhm.
If we need some features to run our code, yes, we need to implement it, but Micronaut aspire to cover everything, and we need to wait some time. You know that Spring is pioneer, and all other guys will follow the Spring. It's 100%. Spring is pioneer, and should be accepted. But for lightweight service with not some custom logic, Micronaut is a great choice.
Okay, good. Thank you very much for answering. So the next question, again, I really want to know more about Micronaut. So you mentioned that in order to rewrite application from Micronaut to Spring, what you did, you just changed annotation and imports. And I'm quite curious, does Micronaut introduce its own annotation or use annotations from Jakarta, like singleton, like context, named bin, and so on?
Micronaut supports Jakarta annotation.
Mhm.
This and has its own annotation. So there are two ways how you can implement it, and no difficulties is here. So I think that's the answer, right? Or
Mhm.
may should cover something more.
Well, yeah, that's definitely an answer. And let's go ahead and talk about other modern features because, Java develops and frameworks which run on top of Java also move forward so that, as far as I'm aware, Spring started to adopt virtual threads. And you can change deep inside go deep into inside the Spring and change one factory to another factory, and well, it works like a charm, and you will start using virtual threads. So, what's the state of virtual threads in the Micronaut at the moment?
Yeah, I like this question. I'm also waiting this feature in Micronaut.
Mm-hmm.
I haven't checked the last version, but what is the last version? But I think soon we will have it, because as I compare Micronaut Quarkus, in Spring they try to cover each feature that they don't have. For example,
Mm-hmm.
Spring Boot didn't have native images, but Micronaut and Quarkus had it, and Spring brought this native. Uh, and now Spring also support this feature, so they compete. And yes, in most cases Spring is pioneer, but uh, it's not elapsed a lot of time before after Spring that Micronaut and Quarkus will support the new feature. So
Okay. Yeah, I see it will definitely catch up rather sooner than later, especially keeping in mind so high level and highly competitive environment. Okay, moving forward, I still want to know more about the Quark Micronaut internals. I'm very sorry for asking so many questions. So see, in Spring, we have a fantastic capability which allows us to create beans programmatically. We can create a configuration class, put configuration annotation on top of it, and create bean. And what's more, we can put fantastic conditional annotations on top of them. Conditional property, conditional on environment, on cloud provider, and so on. Do we have something like that, like after magic configuration in Micronaut?
yes, for example, do you see my screen? Still see my screen?
I can see you, but
We
we
can
can
show
ask
it.
our
We can
we can
show it.
ask our colleagues to make your screen sharing visible.
Let me know if you can see.
Yeah,
It's
yeah, we
visible
can see
now.
now.
For example, look, this factory class is the same like configuration class into Spring. Here we put singleton. Singleton means the bean and with the scope. And here we can put requires annotation. And in this annotation, we can put any information that is depends. This is like, as I said, this is the synonym conditional beans. So it can require some environment, as you can see, property, conditions. You can write your condition, uh, SDK configuration, default values, version, and so on and so forth, and being missing being. So as you can see, this flexibility is also supported by Micronaut. So, and
Well,
even more, you can here write some Java code also in this method to make flexible bean creation. I think this cover this flexibility like Spring provide us.
yeah, definitely. It looks like Micronaut looks like a next big thing which I should learn. Well, and I see that you've been to Micronaut for long, and also you're familiar with Spring. So if I ask you to compare Micronaut versus Spring, what is the main feature which is available in Spring but is not available in Micronaut, and vice versa? What feature do you miss the most?
Uh, what I really like in Spring Boot, controller advice, and I hate it in Micronaut. Their exception handling is horrible. I hope they will change it, but now we have what we have.
Mhm.
Um about features, Micronaut copy all features of Spring. They don't say that Spring Boot is something bad because they support absolutely integration with Spring. For example, we have Spring Cloud config, right? And Micronaut can work with Spring Cloud config, with Spring Cloud bus, these all events of modernization of your configs. They also can respond and react on this. So they can be built in the Spring Cloud ecosystem and fits fluently in this ecosystem and feels great. They just try to adopt it, and what they position themselves that they do AOT generation of the code and use introspection instead of reflection. That's what is the main difference, if simply put, between Micronaut and Spring Boot.
Awesome. Thank you very much for explaining it in such good level of details. I'm really satisfied with all the answers you gave us. Thank you very much.
Yeah, and the last question from my side before we say thank you, final thank you. A bit provocative question. Yeah, from day one, I do that. So for your next project, which framework will you use?
It depends on the size of the service and of the how many custom logic my service will contain. If it will use some standard frameworks without customization, I will definitely use Micronaut. But if I will have the latest version of Spring Boot and have some customization, I will use this latest Spring Boot with supports of virtual threads, and I also will feel myself comfortable because I love Spring Boot. I really love Spring Boot and I love Micronaut, so I love them both.
Yeah, that's beautiful ending. I would say that these are tools, guys. So each tools has its own benefits. So just consider it as a tools. So thank you, Gunnar, very much. Great talk. Thanks a lot for being here
Yeah.
with us.
Thank you, guys. Have a nice evening and have a nice talk. So you have two more speakers with great and absolutely perfect topics.
Great. Thank you very much. Have a good evening. Bye.
Thank you. Bye.
So, guys, we're back. We're back here, and while we're waiting for our next speaker, we have couple minutes. So I will use this opportunity to remind you about our activities, and I will not only remind you. So, Alexander, I have an advice for us. So let's just pick up our phones, and then open Instagram. Now we need to, guys, I do suggest do this with us. So let's do this as a flash mob. So yeah, I have my phone. Yeah, also Instagram here. So yeah, now I will try to make a selfie with all of us here. So how we are conducting. So you will see my setup here. So yeah, something like this. I need me to be in the shot. Yay! Okay, done. Now I need to post it. So I'm posting it right now with you here. So I do think that you should do this with us. So I'm taking Java conference and yeah, like this. So Java conference, my photo, and send. Share. Done. Okay, yeah, that's it. So I do encourage you to do the same. So Alexander, did you have a chance to
Yeah.
do this? Okay, let's do
Yeah,
it.
let me do let me do that. Whee! Yeah, hello. Well, I have a new attendee. We should definitely attend our conference just in a moment. Yeah. So I have seen this request in the chat that I should definitely bring Cinnamon to and show it to our audience. Yeah. So as you will see, hello. I'm not alone on the stream today. This is my dog. She's been with me for quite long, and she's already been to the previous Java on. So she attended so many Java courses, trainings, and conferences. So I see. I think my dog also can act like at least a junior developer. So let me make a selfie with all three of us, you, me, and Wilka. Hey.
That's great. That's great. So, guys, not only people attending Java conference, but also dogs. And I would like to invite to our virtual studio our next speaker. And if you saw his shorts on our YouTube channel, you know that he's also not alone. Adam, hello, welcome to Java Conference 2023.
Hi there. I hope you can hear me and see me well.
Yes, for sure.
Perfect. Hi. How are you tonight?
Very good. So we had two great speakers, and now we have two more. So guys, stay with us, stay tuned. So how's Oscar?
Oscar is sleeping peacefully in a nice living room. Hopefully he won't be disturbed by my yelling about abstractions. If he is, I might need a little bit of a break to calm him down. Otherwise, everything is fine.
Okay, that's great. Mine Oscar is also sleeping in the room nearby, so I do hope he won't not disturb us. He's a bit bigger than yours, guys, than your dogs. So if he will disturb us, he will disturb us for sure. So, yeah, we will dive right into Adam's talk right away. Before we will really do that, guys, I would like to remind you that we have two chats, one on the YouTube and another one on the Weir community platform. And we do expect your reactions, your comments there. So please share with us your opinion, share with us what you think about the conference, your questions, of course. And also, I would like to remind you that on our platform, we have ability to vote for talks and we have ability to give badges for our speakers. So this is how you may share with us your opinion right away. Of course, there will be feedback form after the conference and we will appreciate if you will fill it out. But still, please do this right now because, as I mentioned several times, it's online, and in online it's really hard to really understand that you are there on the other side of the screen. So, and I know that you are there because I see numbers somewhere, but still, it's really good to receive some messages, some thanks, and etc., right in the middle of the talks. So, saying that, I would ask Adam to share his screen. So we would be able to show it, and yeah, two more talks left. Still some online activities. I mean, there. Please make photos for Instagram. Tag us there, and yeah, that's it. What I wanted to share. Adam, good luck, and let's go.
All right. Thanks a bunch. So first of all, before I get started, I would like everyone to get some sort of mobile device or maybe open a different tab on their computer and then scan this QR code or go to menti.com and use this code because you will have some interactions and well, this is the only way to have it other than the chat, but I don't trust the chat, so please. Ideally, you would be watching this on some screen and then you would have your phone nearby anytime some question pops up on Mentimeter. Okay, so I will tap to the next one, and I'd like you to say something if you're in. Hi, hey, yeah, that's perfect. I will wait for a few more people. Let's say 20 seconds. And then we can get started and I will switch back to the main thing. Friday. Haven't heard that before. Grüezi. Okay, 36 and counting. Okay. All right, so back to the main thing. So this is Abstractions, the good and the bad. I'm Adam, hi again. And there is 2 reasons I created this talk. One of them is that I'm just fascinated with abstractions altogether and the way they enable us to create incredibly complex things without going crazy in the process. I think they are the main things that allow us to do that. And the other is that I am passionate about writing clean code. I think writing clean code is one of the nicest things developers can do for each other, and I'm all for that. To me, the best definition of clean code in the book itself is this one. Clean code never obscures the designer's intent, but rather is full of crisp abstractions. So this is not from Uncle Bob, this is from the preface by Grady Booch. And I love this because it's just one rule that contains all of the other rules, right? So if you really understand this one, you don't even have to think about the others. But to use this one, you must really understand what abstractions are. So this will be my first question to you, and we'll head back to Mentimeter. And let's establish a baseline. So please rate your overall understanding of abstraction. So if I say abstraction and you say abstra what, then you just say 1. And if you think I can ask you anything about abstractions and you'll be totally fine and you can explain it to me, then you should put 10. Okay, we have some pretty confident people here. The confident people answered first, and now the last confident people are mustering up the courage to chime in. That's great. So if it's already 10, you can, you might as well leave. I mean, I can't tell you anything new. But if we have an average of 6.7, yeah, I think we can improve a little bit. And some responses are still coming in. Yeah, 5 more seconds. Okay, so we have an average of 6.7. So basically, this audience is fairly comfortable with the concept of abstraction, but leaves some room for improvement, right? Which is great. Now, as the title implies, abstract can be a good word or a bad word. So if after this talk you go out and tell your friends that my talk was pretty abstract, then you probably don't mean it in a good way. But if you're using a new library with a very complicated API and you say, can't they just abstract all of that away? Then it sounds like you're a fan of abstract. Something can be just abstract enough or too abstract or not abstract enough or not abstracted the right way. So there's plenty of material for a talk with this title. It's a huge topic. I won't provide any comprehensive theory, but what I want to do is to first zoom out, get a wide view, so we have a common understanding of what abstraction really is in a general sense. And then we will go down a few rabbit holes, especially related to how the brain works, how that relates to the code you write, what those have to do with each other. And yeah, that's it. If you need a quick clarification anywhere, just post it in the chat, or if you're able to, then unmute yourself. Longer questions, let's discuss those at the end. So let's jump right in. Abstraction is all over the place. As developers, we create them every time we take something complex, give it a name, and hide what it exactly does. And this happens at all scales. So if you are defining some web service endpoints, decoupling the layers of your application, or extracting a method, we have abstractions everywhere. It's our primary tool for splitting a problem horizontally into individually manageable and reusable layers. But abstraction is not just our thing. By definition, and this is the best one I could come up with, there's many different definitions, I would say anything that isn't just one concrete thing, like this iPhone right here, right now, or this table right here, right now, is abstract. And an abstraction is just something that was made to be less concrete or more abstract than it was before. So based on that, if you're a carpenter, you don't create abstractions that often. But if you do any sort of knowledge work, like we all do, then almost everything you create is an abstraction. But who else does it? The abstract of a medical or scientific article is a one-paragraph summary of its contents. So the basic findings are pulled out of the article and presented there. And this way, you can learn about the findings without reading all the details of how they came to those findings. Abstract art is art that's just not concerned with accurately representing things from the real world. Maybe it's a simplified form of reality with some detail removed, or it's completely detached from reality. This way, there's no meaningless elements to catch the viewer's attention, and they have a better chance of appreciating the artist's real intent. In language, every word is an abstraction. It holds much more meaning than just its letters, but usually not more meaning than what you need at the time. So because you have the abstract concept of a chair, you can say, "May I get a chair?" instead of going crazy, looking everywhere for something to sit on and saying, "Please, can I?" Maps abstract away real-world terrain, only showing some characteristics that are important for planning your journey, so you can find where your connection is before you miss it. Now, in some of these fields, abstraction is fractal or at least composite in nature. So you can dig into an abstraction in search of the concrete implementation, but actually, you just find some other abstractions that you can also dig into. So the inside of one abstraction is very often just the outside of another. This is most true in language. There, every word in a sentence is an abstraction that can be looked up in a dictionary and evaluated into a list of other words, which are also abstractions that can be looked up in a dictionary, and so on and so forth. You can keep flipping the dictionary round and round and never leave the realm of abstraction. Luckily, you can combine these abstractions to make up magical phrases that, when uttered, open a window to reality, like "my left shoulder." Software, well, it's similar, but not quite the same. You can debug all day through your code, clicking into all the standard library methods, getting lower and lower, until you eventually find some machine code that you can't click into anymore. So that's concrete now? Well, not really. It's still an abstraction, but you've hit the limit of your debugging environment. But when you execute that code and get some voltage moving in the circuits, well, that's not very abstract anymore, I would say. Interestingly, in art, abstraction is just not composite at all. So imagine some abstract art, for example, some face without any details of the skin, just a few lines. The details are not there at all. If you want to see details, you have to imagine them, and that will be different for every person. So it's just completely different than other fields. So people in all of these fields know very well that they create things called abstractions, and it means something different to each. But there's one thing in common to all of them. All abstraction involves hiding detail for which we don't have the time, the space, the interest, or the brain capacity. And to me, brain capacity, like maybe you saw in the promo, is the most interesting, because if you look at the others, well, you can spend more time, usually. You can get more space, if you get creative. You can pretend to be interested, but good luck trying to get more brain capacity, right? So let's pick that as the next rabbit hole we're going down on. First, a disclaimer. For the next several minutes, you will not hear anything that seems even remotely related to computer science. Instead, I'll babble about mostly cognitive psychology and the likes. And, I'm not a psychologist. But if you bear with me, eventually you will understand why I'm doing this, and I think it will all make sense. So, brain capacity. This has been studied intensively since the 50s, and by now there is wide consensus that in order to learn or understand something new, its parts have to fit into your working memory, which is like the RAM inside your brain. The problem is the working memory can only hold about 4 things at any given time. This does vary a bit between people, so it decreases with aging, alcohol abuse, chronic stress, anxiety, depression. Maybe don't do those things. It can potentially be increased with aerobic exercise and maybe certain memory games like N-back. But practically on any given day, it's a fixed number you're working with. So we will do a quick experiment here. Please log into Mentimeter if you haven't done so yet. And what we will do, you can let me know if you need the QR code again. I need to switch screens to go there. We will play a game. And the rule is this. I'll show you a number for 5 seconds, and you have to remember it. Okay? So, ready, set, go. And that's it. So, get your Mentimeters and tell me, do you remember the number? There's always 2 people who remember. Okay. No way, no way, no way. So almost everybody has responded no way. I'll wait 3 more seconds. Okay. Now, we'll do the same thing once again. Rule is the same. I'll show you a number for 5 seconds, and you have to remember it. And, well, I have to say, this is a bit more fair when I'm doing this live, because it's a bit location dependent. So this might be easier for people who are in Switzerland. You will see why. But even for the others, I think it might be okay. So try to remember the number. Ready, set, go. All right. So same question as before. Do you remember the number? Round 2. Okay, you're all prepared. Everybody remembers? It's almost unbelievable. If you don't remember, please, you should also respond. Okay, so if we compare the first one, which was 4 people remembering and 30 not remembering, and then the next one, which is 32 people remembering and 1 person not remembering. Well, what was the difference? What happened? If you have an idea, just throw it into the chat. I'm interested. But what I think is that the first number, well, that consisted of 10 completely separate digits that had just nothing to do with each other. And the only way to remember them would be to cram each of them individually into your working memory. And, well, you just saw before how large the working memory is. So no way it won't fit. However, with the second number, what did you see? Okay, I'm looking at the chat.
So let me
Patterns.
pronounce these comments so they will not be silent.
Yeah, please.
So we have comments that we have abstraction in case of second number. Number was easy. Just need to remember 4 digits. Patterns, rules, groups. Yeah, also about patterns. Taxi number. Okay. Complexity halved with repeating numbers. And yeah, that is easily separated on groups. I think these are the answers.
Yeah, and some people are also revealed that numbers look like phone numbers. I'm surprised no one mentioned regular expressions. It's a Java conference.
So you would argue that the regex for this one would be smaller than the regex for the other one?
D+/D+, and that's it.
Okay, I'm not sure that's how the brain works, unfortunately, but yeah. So if you're in Switzerland, please also put that word into the chat. You know which word I mean. I'll wait for just 5 seconds for that. Somebody said Grüezi at the start, so I know there are people in Switzerland in the chat. But maybe too shy or not at the keyboard anymore. That's okay. So the second number, well, I think what some of you saw, maybe not exactly like this, but Swisscom, 4 times 4, 3 times 3. So this is a Swiss phone number. It's a made-up Swiss phone number, which is 079. That is the Swisscom provider. And then the rest of it, it's 4 times 4 and 3 times 3. So the thing is, your brains, however you did it, even though you're not in Switzerland, you recognized 3 groups. And fitting 3 things into working memory is not a problem, even if each of them contains more things. So you can remember 10 things by remembering 3. How is that possible? Well, all this is thanks to a built-in compression algorithm of the brain called chunking. Chunking is a fundamental learning mechanism that uses the power of abstraction. It enables you to learn things that are larger than 4 bits. Without this, you couldn't. And it's something that you have by the time you're just a few months old. Now, this is how it works. If you're doing it in a sort of a controlled fashion. You start by looking at a few small things. That you already understand in your working memory. And you figure out their relationships and organize them into a group. Then you give that group a name or some sort of reference. It can be a sound, an image, a smell. And then you move the whole thing over to your long-term memory, which is basically a bottomless pit with huge capacity. And at this point, you have a chunk, one thing that contains some other things. And the cool thing is you can just think of the reference, but still have an intuitive understanding of the whole chunk without thinking of its details. So now the whole thing takes up only 1 slot in your working memory. And then you can form other similar chunks and combine them to form larger chunks. And this pattern is something you can continue practically indefinitely. So in theory, there's no limit, if you're doing this, to the complexity of the things you can understand. Now, I'm curious, is this process something that feels familiar to you? This chunking that I'm describing. So please go to Mentimeter and tell me, is the chunking process familiar to you? Not really, or, well, you've done it before probably, but you don't exactly know that it was chunking. Or yeah, you're totally familiar with it and you know the concept of it. Okay, 10 more seconds. Okay, so we have 6 people who have learned about the theory of learning, 15 people who have learned before in a way that they were quite aware of how they learn, and 2 people who, well, so far didn't notice what they do. It's probably impossible that they've never done chunking, but they didn't notice that they've done it. Okay. So, like I said, this, what I've described, is the controlled way of doing it. Very often, your brain does this in the background in a more organic and messy way, but still, sometimes you can do it exactly like this. And now I will show you an example. So let's say that you just bought your first ukulele and you want to learn Somewhere Over the Rainbow. Like you, I'm sure you know that song. It's legendary. I will just quickly see whether I need to tune here. Okay. One person is unable to respond in Menti. Please let me know if others have that problem as well, and we can look into it. Okay, so you want to learn Somewhere Over the Rainbow, but you have no idea what you're doing. You just bought this, literally. So first, you should learn to make a sound, right? And the first sound we will learn is called pluck, which looks like this. And to do that, when you don't yet know how to do that, you need to concentrate on 3 things. Placement, which part of your finger you put there and where you put it. Angle. And force. So you concentrate on 3 things and practice that for a few minutes, or depending on talent, hours or days. And after a while, you can just think pluck and do it. Pluck and do it. So placement, angle, and force became pluck. And now we have 3 empty slots in the working memory, so we should use them. We have 3 other sounds to learn, each of them consisting of 3 things. Now, we'll just imagine those 3 things that they consist of, but we have the first sound, which is the pluck. We also have the strum down, the strum up, and the slap. Okay, so we've learned those. Now, if we think about all of those, we are thinking of 4 things. So what do we need to do next to learn this, to learn more? Because our working memory is already full. Well, we need to create a group. So first, we will take strum down and strum up and just do both of them alternating. Then we will add a pluck on the 1 and a slap on the 3. Okay, now we are paying attention to three things again, and we have combined them into one. What should we call this one? Well, it is the rhythm. Again, we've combined the strumming and the plucking and the slap into one thing, which is now the rhythm. Somebody can come over and say, remind me, what was the rhythm of Somewhere Over the Rainbow? And you can do, that one. And you can still think of three other things or talk about them, which also uses brain capacity, because the rhythm itself, well, it's now just one thing. You've practiced it, you've chunked it, okay? You could also do something else while you're doing this. So where are we? At this point, our right hand is pretty busy, but the left is not yet doing anything. So what we will do is learn some chords. That's the job of the left hand. Now, to learn chords, well, the easiest way to do it, if you're not that much into music theory, is to just memorize where each finger goes on the fretboard right here. So for the first chord, we can just memorize this one finger here. Then for the second one, oh, sorry, I need to do something. Something broke. Okay. Still not okay. But that's all right. I'll work around it. So for the first chord, we've memorized this one finger right here. For the second one, we will memorize this three fingers here. For the third chord, this one, and these two. So we can learn all of these as a group. First chord, second, third, fourth. But now we have four again, so what do we need to do? We have to create a group. No need for anything fancy, just remember the first four groups. When you're learning music, you will encounter the powers of two lots of times. So just chunking something into a group of four is perfectly okay. Then for the next group of four chords, we can reuse some of the old ones and just learn two new chords. So this is one of the new chords. And one more. But we will reuse two others. So that's the correct one. And we will add one more group, which is just this loner, because it's 9 in total. So we have 3 groups of chords. Our working memory is almost full. We are panicking. How the hell can I learn this song? What do I do now? But we already know. We need to create a group. Now we have the chord progression. And when we're here, we can look at the rhythm again and recognize that, oh, we have 2 things. Why not combine them? So the right hand will do the rhythm, and the left hand can join with the chords. And now we have the whole song. I don't have more screen space for the graph, but at this point, this whole thing is just one chunk. So at the start of the song, there's also some humming by Is. It goes something like this. etc. So once I've learned that as a separate thing, I can just put that and the chord progression and the rhythm together, and then I will have this. Etc. So even without the melody, based on my counting, I just learned something that consists of 41 things. How did I fit that into my brain? Well, it's thanks to chunking. I could do it because I did this in a way that at any one time, I did not have to pay attention to more than 4 things at the same time. So that is the power of chunking. Okay. If we look at what we have now on the screen, it's a tree-like structure with a lot of nodes. Cognitive psychology calls these nodes chunks. Chunking, chunks. But what else can we also call these chunks? I'm looking for a word here. Please put it into Mentimeter and let's create a word cloud. So these 41 things in the song I've learned, they are chunks. What else could they also be called? Okay, 5 responses so far. All of them are correct. There's one of them that's the most correct, but all of them are correct so far. Ten more seconds. Okay, so let's see what we have. Abstraction is in the middle, and yeah, that's what I was thinking of. And we will see why. Roadmap, that's interesting. Leaf, well, some of them are leaves. Patterns, yes, all of them. Partitions, yeah. Memoization, yeah, that's sort of a tricky process that you can do. Yeah, atomic parts, path, encapsulation, lots of good ideas. To me, the best answer is abstraction, and luckily that's in the middle. So each chunk here in the song was created by taking something complex, giving it a name like pluck or rhythm or song, and hiding its detail. So each node is an abstraction. So a chunk is just an abstraction that's created automatically in your brain, and your whole learning process is based on abstraction. From here on, I'll kind of use these words interchangeably: abstraction, chunk, thing. Please bear with me. So let's generalize a little bit. This here is a song I know, but in a more general sense, we can call it internal knowledge. Why did I say internal? Why not just knowledge? Well, it's different from external knowledge, like an application. Finally. Because I would say that an application is just knowledge about how to do something that's written down and executable by a machine. It can look like here, just like internal knowledge. Here, there are both layered hierarchies of reusable abstractions that reference each other. You can see this one, the code one here, as a call graph. So this could be your main entry point, and then below your methods are calling each other. Here we have the left hand and the right hand. Maybe here we have two modules of the two separate modules of the same application. This is collecting some data, and then this is processing that data and creating some reports. For layers, here we had the song. Oh, what's happening here? Sorry. So here for layers, we had the song, the rhythm, the sounds, the muscle control. Here, maybe we have application main, service layer, data access layer, and then utilities and various adapters, right? So the internal knowledge here on the left, of course, that can also be your knowledge about an application. So in this model that I'm proposing, when you're reading and trying to understand code, you're basically moving the stuff on the right over here to the left. Sounds pretty easy, right? Well, these structures can look virtually the same, but often they don't. But I will argue that they almost always should. I will argue that if the stuff on the right already looks like something that could be on the left, then it will be easy to understand. In other words, if we structure external knowledge like code, like internal knowledge, it will be easy to understand. I think when you're looking at some clean code for the first time and you feel like it's just beautiful and you get it, it is because you could move it from the right to the left without having to fiddle with it. And on the other hand, when you've been staring at the screen for 2 hours trying to understand some code, and you even got the rubber duck out, but you're still pulling out your hair trying to understand what's going on, it's because in order to move it from the right to the left, you'd need either some sort of miracle transformation in the middle or brain surgery. Now, the only reason the structure on the left is so good is that it was created by your mind for your mind. So it fits your mind, obviously. It's not perfect. It has problems too. It's a lot of effort to create. If you don't use it, you will forget it. You can mix things up, and it can be terrible to debug, but it fits your mind. Now, on the other hand, well, with external knowledge, there's no such guarantee. Let's look a little bit closely into what this really means. Internal versus external knowledge. The process of creating internal knowledge involves no translation. Basically, these chunks in your brain are code compiled by the machine that is going to run it. So when that is created, there's nothing lost in translation. The resulting structure is well chunked. What do I mean by that? So like you saw before, the details of each abstraction came from working memory of the person who's creating the chunk. So they can be recalled as is and will fit back into working memory. You could also say that the branching factor of this structure, which I like to call the chunking factor, is less than or equal the size of the working memory. Now, the structure is also well connected, because to learn something, you must connect it to something you already know. That's what happens when children keep asking why. They need to get to the point where finally they can connect what you're saying to some chunk that they already have, at which point there is a continuous chain of reasoning between the chunks. Plus, the included content is personalized, because to learn something, you must connect it to something that you already know. not somebody else. Maybe you're trying to explain machine learning to a chef. And first you start by saying, well, it's like, you know, if your dog, we have a lot of dogs here, so that's fine. If a dog behaves well, then you give him a treat. And if he doesn't, then you don't. But the chef never had a dog, never knew somebody who had a dog. Pretty sad life to have, I guess. So it doesn't mean anything for him. But if you say, well, a reward function is like when you have a recipe and you cook something and then you taste it. If you like it, you leave the recipe as it is. But if you don't, then you change the recipe. It will click instantly because the guy is a chef. So this will make sense to you, internal knowledge. Now, this one we won't talk about that much today. But anyway, these are the properties I've noticed that result from the lack of a translation step. There might be others. If something obvious comes to your mind, please put it in the chat. I'm curious. Anyway, it follows that if we want external knowledge like code to match internal knowledge and therefore make as much sense as possible, sparing our brain capacity, then we should replicate these properties as much as possible. So how can we do that? We'll begin with no translation. When you create external knowledge, well, it always starts as internal knowledge. Like someone has a thought and writes it down as text, which is translation. Then somebody else comes and reads that text and translates it again back into thoughts. Today, we'll mostly be concentrating on writing in a way that makes reading as easy as possible. To skip this translation, we would need to download and upload our thoughts directly. Right now, we cannot do that. But good translation may be almost as good as no translation. So, to learn about good translation, we will look at some bad translation. What without why? John is working on some code, this one. And this is his mental model of the code. Pretty similar, makes sense, right? Now, John wants to do something, and so he has some problem on his mind. John comes up with a solution for that problem. John writes down the solution, but not the problem. So he writes down the what, but not the why. The result is John comes back a few months later and has no idea what he's looking at. Or somebody else reads John's code today and has no idea what they're looking at because the chunks do not connect. So a layer of abstraction goes missing. And there, our bad translation has broken our structure, and we no longer have a continuous chain of reasoning. Let's look at a simple example to see how this happens. John's team is working on some new Scrabble game, and he is now implementing the logic to calculate the total points for the round. I hope you're familiar with Scrabble on a basic level. Now, John already has a function that counts points horizontally by checking words from left to right. So he starts by using that. But words are also valid vertically, so he wants to add that. He thinks the best is to reuse this function, but to rotate the board before passing it in. So he looks up how to rotate matrix counterclockwise and does it. So what happened here? John's mental narrative was something like, I need to calculate the total, so I need to take the horizontal, then the vertical, and sum those up. 4 things, right? And then he got into the weeds of how to do that and ended up writing something down. When Jane comes and reads what John wrote, what will her narrative be? I think it's something like look at the code right now. We need to calculate the total, so we need to take the horizontal, then take the horizontal again, but zip and slice and expand the what? Sure, eventually Jane will Google this and understand that we're passing in a rotated matrix, and that basically does a vertical check, but it will take her a minute to realize this. And there you could say, it's a minute. And you would be right, but it's a minute each for everybody reading the code every time they read the code. On the other hand, extracting a function like this also takes about a minute, and you only do it once. Then you can also do this. And if you have this, what is the reader's mental narrative now? It's the same as the writer's. I need to calculate the total, so I need to take the horizontal and the vertical and sum those up. And let's just now think about that minute that we mentioned. We'll go to Mentimeter again. What is the time complexity of this abstraction process if the abstraction is not written down? Like John just did. And then his colleagues will come along and create those abstractions in their minds when they read John's code. Let's see how much of you are into time complexity. Wow, some pretty substantial answers. N squared, 2 to the power of n factorial even. Okay. Well, 10 more seconds. Okay, that's a very even spread. Maybe we need to talk on time complexity then. Well, so in my opinion, based on my calculations, O of n is the right answer. So thanks for those. Because every time the code is being read, an abstraction is being created. If you think I'm wrong, do put it in the chat and tell me why. Now, what is the time complexity of the abstraction process if the abstraction is written down? Please tell me. Okay. Yeah. So I agree with O of 1. The person writes down the abstraction, and everybody who's reading it is just reading it. There's no creation anymore. So which one is better? O of 1, obviously. Sometimes we make these optimizations when we are writing code. Very often it doesn't make that much of a difference. If the code is not calling an external service, maybe we save 1 second per 1 million calls. But reading and creating the abstraction in the mind takes a couple of seconds or minutes or hours. So if we optimize this one, we definitely save a bunch of money for the company. In any case, I think abstractions lost in translation may be a primary reason for Kernighan's law. Debugging is twice as hard as writing the code in the first place. So if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. So what can we do about this? The solution is very simple. Notice that John was implementing the rotation. When he was doing that, his mental narrative included all the right words that should be written down. Now, if you think in English and code in English, then just write down what you're thinking, the way you're thinking it, and you won't have abstractions gone missing. And here, I'm actually curious, are you doing this? What language do you think in when you're writing code? Please tell me, because this is the easiest if you're thinking in English and then coding in English. You're thinking in good language, okay. That's pretty abstract. Russian, okay, English. Let's see. Somebody is able to think in a programming language. Well, multiple people are able to think in programming languages. That's amazing. I can actually believe that. But anyway, English seems to be winning. So for now, let's leave it at that. And people who are not thinking in English when they're coding, yeah, I think their job is substantially more difficult. Okay, now, if this principle here looks a bit too simple, it's because it is. It solves the problem if you're working alone, but if you're in a team, you need something more. Sarah is an exceptionally clever girl who studied at MIT, runs marathons and plays memory games for fun, so she has a working memory that can hold 7 things. As she codes, she writes down all the abstractions in her head beautifully. So everything is fine for Sarah. But when her average colleague tries to read a method she wrote, by the time they are finished, they will have forgotten where they started. So by doing exactly what we said you're supposed to do, she has broken the structure for others in a different way. So there are too many chunks in the chunk. Our chunking factor is now larger than the size of the average working memory, and we no longer have a well-chunked structure. It means there's now too much detail to fit into the working memory. The reader is overwhelmed and cannot see the forest for the trees. And they need to do some mental gymnastics, create the missing abstraction in their head every time they read the code. In the end, this is also a missing abstraction, but the difference is the abstraction was never there in Sarah's mind because she never needed it. Now, I won't bore you with an example here. All of you have seen methods that just do too many things, and you can't process them all at once. Now, to avoid clutter, we need to limit the chunking factor. Based on what we've learned, if this is more than 4, we should probably hide more things. So we could have a simple rule like the 4 things rule of abstractions. Abstractions should not contain more than 4 things. But can you say how many things this is? Let's go to Mentimeter and please tell me. Seconds. I put 66 because, I put 66 at the maximum because there's the number of characters, right? Okay, let's go back here. Without a graph, it's much more difficult. In the literature, a chunk is the largest meaningful unit in the presented material the person recognizes. But for different people, this largest meaningful unit is different. If you're just learning to code, it might be 7 things: the type, the variable name, assignment operator, object, method, parameter, end of statement. It's already too much. But with some experience, maybe we get the foo from the DAO based on ID. Now, as your experience grows, your chunks become larger and larger. And that's it. I don't think we can count chunks. Something that might come close is the cognitive complexity metric offered by some tools. This will provide a precise number, but I don't like it that much because it tells you, hey, your method is 53. Do something about that. It makes me uneasy. What does it really mean? I'd like to propose something else, which to me is more fun. Previously, we said you should write down what you're thinking. Let's refine that a bit. Every level of the abstraction hierarchy should be fully expressible as one simple sentence we can tell our average colleague over a cup of coffee and have it understood and repeated back to us. The words of that sentence should actually be written down and emphasized. If all of that checks out, you have hidden enough things and no counting was needed. If by the end of the sentence you've forgotten where you started, didn't fit your working memory, if your colleague couldn't repeat it back, it didn't fit their working memory. Filtering happens automatically. Now, if your colleagues are not talking to you, the colleague can be a rubber duck or something that I'm sure many of you are talking to nowadays, AI. Actually, this week I did what everybody else was doing this week, and I created a custom GPT in order to help me with rubber duck design. But I have to say, so far, I'm not very impressed with the results. For example, here I've inputted the code that we've discussed before, and 3 out of 4 times it told me that this abstraction is perfect, and it mentions horizontal and vertical, even though it doesn't. If you're interested in this, post it in the chat. I will share the link. You can play with it. But so far, I don't think it's good enough to use. Even though we might use AI for this now, I like to call this process rubber duck design, because the rubber duck encapsulates the idea that just saying something out loud will create some sort of magic that helps you get a clearer understanding of what's in your head. So we use rubber duck debugging to help us read code and rubber duck design to help us write code. Now, I think I still need like 5 minutes to finish. Is that okay? Do we need to rush?
We need to rush.
All right. In that case, I'm going to skip a few things here. There was another translation issue that could happen here, which is basically over abstraction, which is not enough chunks in a chunk, which is the opposite of what we've discussed so far, but it results in the same thing, an overloaded working memory. So, skip a few things here. And let's summarize. Abstractions are all over the place. Many disciplines use them for many reasons, one of them, and the most interesting, being to spare our brain capacity. Our active understanding is limited by the size of our working memory. We get around this limitation by using a process called chunking, which creates abstractions in the brain automatically. When we write code, these abstractions in our brains are translated to abstractions in our text editor. This can go wrong in many ways, resulting in missing abstractions, under abstraction, over abstraction, or the wrong abstraction. The fix is very simple, but very often it doesn't happen. You just have to listen to the abstractions in your head, say them out loud, discuss them, write them down. Now, at this point, I would like to ask, and I promise just 20 seconds, after this, please rate your overall understanding of abstraction like you did at the start. Okay, I like that. And we even had to skip one section. So that's nice. I think that's like a 2-point improvement overall. Very nice. Now, if you remember only one thing from the whole talk, please remember that the power of abstraction is built right into your brain. You just need to take what it gives you whenever it gives it to you. So thanks a lot. And if you feel like you would like a summary of this whole thing, you can scan this QR code and download the PDF. And that's it. Thanks a lot for your attention.
Great. Thanks a lot, Adam. Thanks a lot for your talk. I'm a bit sorry that we had to skip some sections, but still, thank you. Thank you very much for such a great thing on our conference. So it's not first time. I'll be honest, it's not first time I hear this talk, but it's just still awesome. So thank you very much.
Glad to hear that.
Okay, so thank you very much. Thanks for being on the conference, and have a great evening.
Thanks a bunch. You too. Enjoy.
So we are close to the finish of our conference, and we already quote Apple today several times. So one more thing, I would say one more person, like the person.
Yes, definitely. This
So,
is rockstar of the day, I think.
Yeah, I would say the same. So, guys, please welcome Josh Long on Java Conference 2023. Hi, Josh.
Good morning, or evening, or afternoon. I don't know. That's like
We have people all around the world, so yeah, anything will be perfect. Hi, how are you doing?
good. Thanks for having me here. I'm super excited. It's nice.
Yeah, we are excited as well. So, guys, we encourage you to ask your questions. I remind you that we have two chats, one in YouTube, one on our platform. You can ask questions in both of them. We will try to ask all of them in the end of the talk to Josh. So please share your questions, share your comments, share your thoughts during the talk. Everything is can be in place. So I think we should not spend any more time. I would ask Josh to share his screen. And after that, let's start.
Okay.
Also, yeah. So let's do that.
Let me see. Okay. I'm going to share my screen. All right. Entire screen. Go. Share. Aha. Okay. Very good. Hi. My name is Josh Long. It's very good to be here with you. It's 9:10 in my time, local time. So what do we have? 45 minutes, an hour, 2 hours, 7 hours? What's the
We
budget?
have an hour, but you can have as much time as you want.
I'll try to stick to an hour. My name is Josh Long. It's very good to be here. Like I said, I work on the Spring team. I'm a Kotlin Google developer expert and a Java champion. And I'm just really happy to be here with you all today. I love virtual conferences. I love online content. If you don't mind a shameless plug, I have a YouTube channel there, youtube.com/coffeesoftware. It's not terrible. It's not. And by the way, we're using a StreamYard for this, which I also quite love. I use it all the time. It's a good choice. So anyway, I work on the Spring team, and my friends, it's November 17th. And you know what that means, actually? I forgot to tweet that. There are, 7 days, right? So it's November 17th. We release on, 6 days? On the 23rd. 6 days until Spring Boot 3.2 GA comes out, okay? That's awesome. So good stuff, right? We've got that. There are 6 days. That's amazing, right? We're in an amazing time. Spring Boot 3.2 comes out next week on Thanksgiving. In the US, we have the holiday of Thanksgiving. It's a great time of the year to be thankful, and I am thankful for this release. You see, I think we are in a point in our history where we can say there's never been a better time to be a Java developer or a Spring developer, right? There's never been a better time to be a JVM developer, and I say that fully aware of where we sit in the scheme of things, right? If you look at the history of things, right? So if you go here, spring1.io, history of Spring, we have a little video game you can play. It's this year we celebrate 20 years. So you can look at the history. Rod published the first book in 2002, 2003. We had the first early access builds of something called Spring, and then 2004, Spring Framework 1.0. And then, of course, you can keep going. And if you go real fast, all the way over here, come on. You get over here, and you can see now towards the 2015 era, we get Spring Cloud. By 2014, we had Spring Boot. 2013, we had the first early access builds of Spring Boot. So it's been 20 years of Spring Framework and 10 years of Spring Boot. And just keep going all the way over to the end. And you can see it's just been an amazing journey, right? And I say that there's never been a better time to be a JVM and Spring developer. I say that knowing that this year we mark 20 years of history, right? It's an amazing time. And that's just, it's hard to overstate that. So like I said, next week we're going to celebrate Spring Boot 3.2. It's going to come out. This release is huge, and it builds upon the 3.x sort of generation of software, the 3.x Spring Boot line, and there's just some amazing stuff there. So my friends, let's just take a look at that. We're going to go to my second favorite place on the internet. Obviously, my first favorite place is and has always been production. I love production. You too should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. And my friends, we're going to build a new piece of software. So I'm going to use Java 21. So for the moment, things are a little loosey-goosey with Gradle. So we're going to use Maven, okay? I had a New Year's resolution this year. I still have it, but it's just not going so well. My New Year's resolution, I had two. One was to lose weight, and two was to learn Gradle. And anyway, the Gradle is going well. It's going well. I'm definitely learning Gradle. But anyway, for now, we're going to use Maven, okay? I like Gradle, but it doesn't quite work with Java 21, so we use Maven. Then we have to choose the version of Spring Boot. We're going to use the latest and greatest. But again, 3.20 RC2 will be GA. And again, when? On the 23rd of November. So just a few short days, okay? Next Thursday, actually. Next week, minus 1 day, right? Next Thursday, it'll be GA, and that'll be wonderful. And then we have to choose what we want to name our software. Friends, I'm going to name it Service. And the reason I'm going to name it Service is because I'm really, really good with names. I get that from my father. My father was also really good with names. When I was a small boy, we had a small white dog, and my father named this small white dog. He named it White Dog. Now, this dog was with us for like 10 years, and I don't know what happened to him after that. I think maybe he got a job or something. I don't know. He disappeared. And then suddenly, magically, we got another small white dog, and my father named this small white dog Two. Now, I'm not sure if it's TOO or TWO or what, but either way, great with names. I get that from my father. My mom, however, she tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. So, okay, we're going to call this Service. And then, of course, we're going to choose Java 21. Friends, you have a number of different choices here. You have 4 different radio boxes. But, friends, there are only realistically 2 valid choices. And really, if you think about it, only 1 really valid choice. You see, in order to use Spring Boot 3.x and later, you need to use Java 17 and later. So these other 2 radio boxes, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never select these versions of Java ever in any context whatsoever. These are completely unacceptable, except to show people, ironically, what they should never do. And I think you should be using Java 21 because, as we'll see, if you don't use Java 21, and you don't take advantage of the features in Spring Boot 3.2, you're just burning money. If you don't like money, then by all means, use Java 17. But if you do like money, then use Java 21. I think the choice is pretty clear. And I think, these are technically amazing releases. Java 21 is technically superior in every way. compared to Java 8. It is syntax rich, it is robust, it's operations friendly, it's secure, it is technically superior in every single way compared to Java 8. It is also morally superior. You won't like the look of sadness and despair and shame in your children's eyes when they find out that you're using Java 8 in production. So don't do it. Be the change you want to see in the world. Do the right thing. I'm going to use Java 21. And by the way, if you're not already persuaded, then I think we can all agree, just judging purely by the version number alone, that Java 21 is greater than Java 8, okay? Almost 3 times greater. So we're going to add some dependencies. We're going to use the GraalVM native image support. We use DevTools. We're going to use the test containers support. We're going to use Postgres. We're going to use the web support. We're going to use the JDBC support. I hit enter by accident. Let me clear that up. Okay, good. What else do we need? JDBC, web, Postgres, test containers, GraalVM, DevTools. I think that's it. I think that's enough for now. Okay, so and maybe we'll bring in the actuator as well. That's fine too. Why not? Okay, so good. So we're gonna go ahead and I'm not even sure if we're gonna have time for this. Let's try. Okay, we'll try. So I've got a new service. I'm gonna hit generate. I'll open this up in my IDE. Let's see. Here we go. And it doesn't matter what IDE you use, so long as it supports Java 21 and Maven, which of course all do. By the way, for those of you using Visual Studio Code, did you all see the new Oracle Java Platform Support extension that provides? It's basically the NetBeans editing experience packaged up as a Visual Studio Code language server, which is super good, right? That's super cool. So now instead of having to download 5 different plugins from Microsoft and Red Hat and all these other wonderful organizations, you can just get one unified experience inside of Visual Studio Code. It's pretty good. I like it. Okay, so we have a new application. This is our production code, but friends, we're not going to start here. You see, I want to live that git, clone, run lifestyle. I want to be able to take my code, git clone it, and then start making changes to it immediately. And to that end, in Spring Boot 3.2, we have added, 3.1 back in May, we added new support for test containers and Docker Compose. And the basic idea here is that when we went to the initializer, it code generated for us in our source test Java code here, source test, not main, test. It code generated for us a Java configuration class with extra bean definitions and a public static void main method. So this is a main class, just like the one in the production code, but it's good for running during development. And we're going to run this, and what it's going to happen is it's going to start up the application, and each time it starts up the application, it's going to also find the extra test configuration here, Java configuration that you've seen before, and register those beans as well. And these are only useful during development. One of those beans is a Postgres test container. Test container is a Java API for working with and standing up Docker images from Java. So this bean, when it gets created, is going to call the Docker daemon and then do Docker run Postgres latest for us, which is great. But that's a little bit problematic because remember, I want to move quickly. I want to go fast. And if I make a change to my code, I'm going to then restart the code, and it's going to restart the Docker image. I don't want that. So instead, I'm going to use DevTools, which is a great way to make really quick changes without having to do a long restart. But I don't want to wait for this. So I'll tell Spring to not restart that on every single DevTools build. I'll use this @restart scope annotation. Okay. So now let's go ahead and run just this class, public static void main, in the test code, right? During development, this is very convenient because what's going to happen is we're going to start up the Postgres container. You can see it starting there. There's the Postgres Docker image and all that. And then we automatically created a URL for you for the data source. That's what this @service connection annotation is doing for us, is identifying this as a thing to which we can automatically connect. And by the way, that if you don't know much about Spring auto configuration, what normally used to happen is you have a class that starts up when the program starts up, and it looks at the environment and it registers beans. One thing that we used to do, is we take properties from your environment or your property files or whatever and map them to Java objects. And then, so, spring.datasource.url becomes a variable that's of type URL on a object that has the prefix spring.datasource, right? And so it's pretty natural. It's a type-safe way of moving properties around. And then in our auto configuration, we take that properties object and then use it to create, let's say, a data source, a Javax SQL data source, or a Jakarta SQL data source, or whatever. And that's worked fine for years and years and years, like 10 years, right? But in 3.1, we changed things a little bit. Now, we create, from those properties, we create something called a connection details. And then from the connection details, then we create the actual data source. Why the extra step? Well, now we can create connection details from other things besides just properties. One of the things that we can create it from is Docker instances, Docker images being run in the Docker desktop or Docker daemon, right? So we can actually automatically connect to that instance and get the credentials from there, right? They all export their credentials for you to use. So now I don't have to specify Spring data source URL and Spring data source username and Spring data source password. Same thing for MongoDB and Cassandra and all these other things. I don't want to have to specify credentials when the Docker image already has that. That's what this annotation does. And by the way, that connection details, it's a hierarchy, right? It's a hierarchy of types, but it's kind of funny to me if you look at the actual interface, the marker interface, because look at this interface. You can see it's very complex, very, very complex, but yet look at the author text. There are 3 authors here. I don't know why. I'm just wondering what happened in this discussion that meant that 3 people had to be involved. But anyway, it works. And by the way, like I said, it's a hierarchy. Okay, so it might have just been that they refactored the code out of there and it got moved to other places. Okay, so we've got this public static void main. We've got our database. We're already up and running. This took a long time. Remember, we had to start the Docker image. It took a long time. But we don't have to worry about that going forward. So now what we're going to do is we're going to build a data-centric application. I'm going to go to here. I'm going to create a schema file and a data file. So schema.sql, create table. If not exists, customer, ID, serial, primary, key, name, varchar, 255, not null. Okay, and then data.sql. And I'll say delete from customer, and then I'm going to insert some data, just some sample data, so that we have something with which to work. Say, Josh, hi, I'm on the Spring team. Who else is on the Spring team? We've got Jurgen. Oh, nope. That was the wrong accent, my friends. Don't do that. There you go, Jurgen. We've got Madura. We've got Olga. We've got Violetta. We've got Yushin. We've got Stefan. Sorry. We've got Spencer. There you go. There's 8 people. Okay, so we've got now 8 names in the customer table. The table is called customer here. And now I want to tell Spring Boot to automatically run these SQL files when the application starts up. So I'll say SQL init equals always. Okay. Now I want to build an application that actually uses that data, and so I'm going to create a simple record here. Okay, so record integer ID string name. Now this is a record. I love records. I love these so much. I mean, this just makes life so much simpler. The basic promise here, the basic contract here, is that Java basically is a very simple language. And in Java, we have this new thing called a record, which is basically what other languages call tuples. The thing is, in Java, everything has to have a name. It's a nominal language, right? And so in Java, we don't just have unknown anonymous tuples. We call them records. They have a name, right? But they have the same contract as a tuple. They're a sequence of variables of whatever type that we can stash there, and whose identity is equal to the identity of the constituent variables. And when I say variables, I mean the components that are passed into the constructor of that record. So the ID and the name. The identity of customer is equal to the identity of ID and name, okay? And records, if you agree to this contract, then the language can do some amazing things for us. It can give us accessor methods. It can give us 2 strings and equals and hash code and all this other stuff that you get for free just by using a record, right? So it can do that because it makes that contract with us. And it also knows how to unpack one of these objects. It knows that in order to make another customer, we just need an ID and a name, right? And so it also knows that if we want to like extract out variables, we can extract out the state of the object by extracting out those components, these constructor components. Records have a lot of depth, and actually they enable 1 out of 4 big features that are in Java 21, which is what we're using here, that the Java language team is calling data-oriented programming. right? And the idea here, friends, is that in Java, historically, Java has been very dominant. It has succeeded in the era of the monolith because it's very type safe. It's got good package privacy protection and access controls, and it's very easy to create nice, clean, object-oriented hierarchies. And this is great in a monolithic application where you have large, deep-seated hierarchies of types, where the dispatch is in terms of implementations, polymorphic implementations of those types. That's dynamic data. That's dynamic, dynamic dispatch, right? That's a very common precept of object-oriented programming. But increasingly, friends, as we move into the era of the cloud and small, singly focused individual microservices, we're not building deep-seated hierarchies of abstractions anymore, right? We're not using dynamic dispatch anymore. Instead, we're using things like messages. We're sending messages across the wire from one side of the program to another and from one program to another. And that is data. The way we communicate, the way we express change in a system is now in terms of the data that we conduct through that system. And so the language naturally has to evolve to support these kinds of data-centric use cases, right? And the language has, and it has four huge features. We have records, which we just looked at, right? Sealed types, right? And then, of course, pattern matching. And then, of course, this smart switch expression, right? These are all things that taken together support data-oriented programming, and it just comes together in Java 21, which is a huge deal. So let's just take an example here very quickly here. So imagine I'm working in a highly regulated organization, and I've got a type called a loan. Well, loans are, they're monetary instruments. They're heavily regulated in lots of industries. It's very important that when you have a loan type in your code, that you handle all use cases consistently, right? You don't want people just creating new anonymous subclasses of loan and then passing them through to make something work. You have to make sure you're handling all the cases correctly, right? So you want the compiler to help you. So I'm going to say that this is a sealed type, okay? And I'm only going to permit 2 specific subclasses. And maybe that subclass is sealed loan, implements loan, okay? And then not sealed, secured, right? Secured loan. We're going to say secured loan and then unsecured loan, right? So we've got 2 different types. I'm going to explicitly permit those loans, unsecured loan, etc. And so now the compiler is saying, okay, look, you want me to guarantee that there are only 2 implementations, but this class is still public. It's still not final. So I can either make it final, in which case that gets better, or I can make it sealed as well, right? Or I can make it a record. But either way, I need to guarantee the compiler that I'm not going to change these subclasses. There, now everything is happy. The language knows what sealed types we have. It knows that these types are as many types as we've got. And this is a new kind of access control, right? These types it's not just public or private or package private. It's a new kind of visibility, which is it's sealed or not, okay? So good, so this is better. Now, imagine that my secured loan, the interest rate is gonna be very good. It's fixed, all the good interest rates, all the good applications get really, really good loans. It's all the best. They get the same rate, okay? But what about the unsecured loan? Well, this depends on credit history, right? This is going to be very different. So let's imagine that this is actually a record, and we've got some state here, okay? So it'll be float interest, okay? And now let's say I want to build a message based on those loans, okay? So I'll have a method here, display greeting for user loan, okay? And I'll pass in a type of loan. And, I could do something like this. I could say, okay, if loan, instance of secured loan, well, then I have to downcast. I can do that like this. I can say secured loan and then loan. And then I can say, okay, return, good job. Nice interest rate or something like that, okay? And then I could say, okay, if loan, instance of unsecured loan, then I can say var USL unsecured loan equals loan. And I can say, ow, that USL dot interest is going to hurt, right? Something like that. I don't know, whatever. Imagine a very cruel bank, right? So this kind of works, but it's kind of ugly. So let's use our first taste of pattern matching. The first thing is we can actually unpack this. We can say secured loan And we can use this, we're identifying with pattern matching. This is the matching phase. We're identifying that this is a type that can be cast down to that. And then we're extracting by creating a variable so that in the context of this if statement, we can say that this variable is definitely castable, okay? And I can do the same thing down here, okay? So let's do USL, there we go. So now this code is definitely castable within this context, within that scope, and so it's easy to work. But still, this is a little bit flawed, right? Like I have a default case here, I guess, but why do I need one, right? I've only got 2 objects. Why do I need this? And I need it because the language, you know, it doesn't know that that's all that's going to happen. The other thing is, what happens if I get rid of this? Well, now I'm not handling all the cases, am I? Right? I'm only handling one. Does the compiler care? No, it doesn't. So I've got this unnecessary default case. And in this case, if I comment went out, I'm not even handling a case, and the compiler hasn't helped us out at all. So one way to get around this is to switch to smart switch expressions, right? Get it? Switch to. So I'm going to switch on the lone type itself, not an int, right? Not an enum, but the lone type itself. And I'll say, okay, case unsecured lone, right? USL. Then we can return this. Good, look at that, okay? Look at that, I can return an expression from each branch, no need for a break. And then from this one, I can say secured loan, SL, and I can return that, okay? So here, there we go, good, good, good. So now, well, first of all, I don't need this, it's extra, good. And now the compiler's happy, I'm still using pattern matching, but what if I don't cover a case? Okay. Wow, the compiler's saying, hey, you didn't cover all possible input values. So the language is making it cleaner to do what I'm doing, and it's making sure the compiler yells at me if I forget to handle a case. This is super good because that means it's not possible to like not handle a particular branch. And you might say, oh, well, I can use the visitor pattern, but that's just it, right? That only works if you know all the known states of the instance of the type. But if you forget to account for that, then you're going to miss a branch, right? This is the compiler helping you, and it's actually very clean. It looks, you know, it's much better than a regular switch expression. So, okay, so we've got now pattern matching. You saw our first taste of that, but even this, I'm dereferencing the unsecured loan just to get access to the interest. Well, remember, unsecured loan is a record. The state of the object is the components of the object. So I can actually extract out that interest into its own variable and dereference that directly. I don't need the container, right? There you go. So the language is now doing smart pattern matching based on these, and you can even do when branches. You can say, okay, when the interest is equal to this, then extract it out or whatever, right? So there you go. I've got now a nice message. I've got sealed types. I've got records. I've got smart switch expressions and pattern matching. These things make it really easy to build services with messages, with data. And this is increasingly what you'll see when you build microservices, right? Ad hoc messages coming in over the network from Kafka or REST or whatever. These are stringly typed messages, right? And the language is now built for this kind of stuff. It's really, really elegant to deal with this kind of data-centric processing. Good stuff. Okay, so even though I used a record here, remember, this is just the beginning. Okay, we are just looking at the very beginning of the possibilities here. The next thing I want to do is I want to build a repository to talk to that, right? So I'll build a customer repository, okay? And here I need to talk to the database. Friends, one of the new things I can talk about in Spring Boot 3.2 and Spring Framework 6.1 is the new JDBC client. Now, if you've ever used Spring's famous 20-year-old JDBC template, right? This thing has been here forever. This type is how a lot of us got into Spring. This is how I got into Spring. It's a way to just use regular JDBC. Well, look, it was written in May 2001. This class is 22 years old. Closer to 23, right? It is a very, very old class, and it is amazingly useful, and it's been around forever, and it works really well for like 99% of the use cases, and all you need is a data source, right? So a lot of us, like me, I started using it in 2003. I started using it just to bring this class in. I didn't even get a chance to use the rest of Spring, but this was so useful. I was like, I need this. But the problem is, this is like super useful 99% of the time, unless it's not. In which case you end up in one of these overloaded methods that has like a million different parameters and that you kind of have to do all the work yourself. If you find one of the overloads that does exactly what you want, then it's beautiful. But if you find something that isn't accounted for, then you end up doing a lot of work yourself. Well, we want something where it's like more granular. Instead of like 100% or 10%, what if you could just add 10% each time, right? You can compose more granularly. And so that's what this JDBC client is. It's a fluid DSL style API for working with JDBC, but it has a lot of the same types as you would have from the JDBC template, including the row mappers and the row callback handlers and the results extractors and all that stuff. It's got the same types as you're familiar with from the JDBC template, but it's a fluid DSL style. If you've ever used any of the reactive stuff, you might recognize the R2DBC database client, right? Very similar style, but this doesn't use reactive. And we'll talk about why that's not a big deal in a bit, okay? So let's create a method here, okay? I'm going to create a method to return all of the customers from the database. So customers, okay, like that, return this.jdbc.SQL, select all from customers. And by the way, this is another thing that's in Java now these days that wasn't there before, and it just feels so much better now to use straight SQL, right? Now look at that. So select all from customers, and let's see, I want to do a query. I'm going to do a query with a row mapper, so I'll say RSI and new customer rs.getID, rs.getString name, okay? I'm going to turn this into a list and return that. So now I've got a very simple query that just returns all of the records and then maps each row into an object. And you can see how nice it composes, right? I can actually just reuse this too, because maybe I want to put that up here and then reuse that lambda to map other results from the customers table. So what else might I do? Well, maybe I have customers by name. Okay, and I can say string name, return this.jdbc.SQL. Okay, and I can say select all from customer, and by the way, it's customer, not customers, where name equals this, param name, query this dot that, and then list, right? Good. So now we have our simple methods to return the results. Good stuff, right? We did it. Good stuff. So now we have these two repository methods. Maybe I want to build a simple controller to talk to that. Okay, so create a response entity, response mapping, customer controller. Very good. And I'll use that here. I'll say private final customer repository. Inject that into the constructor, and I'll say at get mapping customers. Right, collection of customers. Turn this dot repository find all. Whoa, hey, come back. There you go. This dot repository. Okay. Dot customers. Good. So let's actually try this out. So do I have the program running? I do. So I'm going to make a change. I'm going to do Command Shift F9. I just did rebuild. That's this right up here, right? Command Shift F9 is recompile. And you can see the original, when I started it several minutes ago, it took 2.4 seconds, which is an eternity. Nobody has that kind of time. This time, it took 0.3 seconds, right? So it didn't have to, it's almost an order of magnitude faster to do DevTools reloads than it is to do actual reloads, right? Because we don't have to restart the JVM, right? And we don't have to restart Postgres, which is also very good. Okay, so now let's try it out. Customers. It's saying we don't have select all from customer. We don't have that table type. Oh, because of the, I think it's because I changed this and it's not getting picked up. Okay, so let's fix that. Restart. Okay. And customers, it's saying select all from customer. Well, what's the issue here? Schema.sql, customer, data. Okay, and okay. And then application.properties. I feel like I did everything right. What did I do wrong? Source main resources, data.sql. Select all from customer. Select all from customer. Oh, there. Sorry. Command Shift F9. And now it's saying the view result. Okay, now I have to make the controller correct. So we go over here. Where's my controller? At response body. Command Shift F9. Take that again. And there we go. Whew, okay, so we have our data. Now we have our HTTP endpoint. I want to create another endpoint here for the names, right? Get the customer by their name. That's easy enough. So we'll do that here. Customers by name, path variable string name. And then we'll just say by name. Okay, Command Shift F9. go here, Josh. There we go. It's worked. Great. We're moving quick. We've got our data in the database. We're using data-oriented programming. We've got nice fluid DSLs to get super fast, efficient performance. By the way, you could still use an ORM. We have Spring Data JDBC. We have all these other things, but you can use whatever you want. I just like the low-level JDBC client a lot, so I wanted to show that to you. Okay, so we've got our simple data access. We're talking to the database itself, but what if we have data somewhere else? What if we want to get some facts from another API, for example, okay? Well, there's a couple ways we could do this. One is we could just build the client ourselves. Let's say we're going to build a cat fact client, okay? Uh-oh, I heard my dog walking around. He's offended that I'm going to talk about cats. So we're going to inject here the the REST client. This is another new thing inside of Spring Framework 6.1, and it's the same kind of use case. We have the REST template, but sometimes it feels nice to have these fluid, composable DSLs. So we have this instead, and we have to define this bean. Now, friends, here's a pro tip. When you create the REST client, inject the builder like this, and then use that to specify the request factory, because the default to retain compatibility with the REST template, the default is to use the old request factory, which uses the Java net URL abstraction, which is a very old client. It doesn't even support options, right? So instead, we're going to use the java.http JDK client. That's the new one, right? And this is much better. So specify that. Now I've got the REST client. I'm going to inject that here, and I'm going to make a call to a web API called the Heroku Cat Facts API. Okay, go here, and here's the documentation, and it's just that URL. Okay, and we're going to say, okay, record cat fact. Okay, string text. We're going to insert that here. Collection cat fact facts. Good, and then we're going to say return this dot http dot get dot URI dot facts dot retrieve dot to entity new parameterized type reference of collection of cat fact. Okay, so there's this, and actually we don't need the to entity, do we? We just want the result. So we'll take that to body. There we go. Okay, there we go. So that'll give us a collection of cat facts, right, that we're going to return. And actually, it knows by the type there, so we can just do that there. So now we're using the new fluid DSL, and again, same thing. You can use a lot of the same types that you used from the REST template. A lot of them here, like the message converters and HTTP message converters and things like that. Those all work as well. So let's now try this one out. Let's create a cat fact controller. Okay, at controller at response body cat fact controller. Okay. Cat fact client. Cat fact client. Okay. That, and we're going to say git mapping facts collection cat fact. Okay. Return this dot cfc dot facts. Okay. So now Command Shift F9, go here, localhost facts, and you can see it's made a call to the service, and we got the results back. Fantastic. Okay. Now think, this is pretty good. I like this, but this took a lot of work. I had to write all of this code, right? This cat fact client. Another new thing we have in the Spring Boot 3.0 line is declarative interface-based clients. Now, so we can actually just reduce this down to one simple interface. We're going to say interface cat fact client, and we're going to take a method here, collection cat fact facts, and I'm going to use the get exchange annotation, and we'll just pass this URL in. Pretty simple, huh? So do that. And then we can delete this code, and we have to define this interface as an actual bean, and we can do that now using a generic mechanism. And this works for RSocket as well, so you can do all sorts of stuff. So we're going to say HTTP service proxy factory dot builder dot build dot create client cat fact client dot class, and we need to specify the builder. And the exchange adapter. So it's going to be a REST client adapter dot create, passing in this REST client that we just defined earlier. Okay, so pass that in. There you go. Okay, so now we've got this chain of things, but we're basically saying create an actual bean out of this interface that we can use. So let's go ahead and reload the configuration again, make another call. There you go. You can see the same exact functionality, but we didn't have to write the client, right? Much better. We're still using the controller, of course, but the client itself is done for us. Okay, so now, what are we doing when we make that network call? When we make that network call to the Heroku service, what's happening? Well, we're waiting, aren't we? This behind the scenes, this is using input stream and output stream to make the request. So when we get the input stream and we call input stream.read, we're waiting for the next byte to arrive, waiting for the next byte to arrive, waiting for the next byte to arrive. How long does that take? We don't know. Hopefully you've specified a timeout, but there's really no way of knowing how long that's going to take. And that's okay if you've only got low traffic, but if you have a high enough number, you're going to run into problems, because for every single request you make, you're making that request on a thread, and that thread is no longer available to anybody else in the system, right? This is a big problem because you're wasting that time on that thread. So let's take a look at an example here of what I mean. And this is an example from my friend Jose Pomar, a Java developer advocate at Oracle. I'm stealing it blatantly and brazenly and unashamedly from him. I'm sure he would be okay, but let's just take an example, okay? Threads, okay? Let's just see an example here. Return new this, and merci, Jose Pomar. Okay, there we go. So we're going to create a bunch of threads here. Okay, threads. New array list of thread. And we're going to say for var I equals 0, I is less than, let's say, 1,000, I plus plus. And then for each thread, var index equals I have to create a local variable. For each thread, for each number, I'm going to say threads.add. And I'm going to create a new regular platform thread. I'll say thread.ofPlatform.unstarted new runnable. Okay. And then I've got now 100 or 1,000 threads, right? That's what that is, 1,000 threads. And in this thread, we're going to do some work and we're going to waste time. Okay. Let's talk about that in a second. But before that, once we're done with all that, I'm going to go through and I'm going to start each thread. So I'll say threads.start and then do a join to make them all wait until they finish. And then I'm going to print, and then when I'm running the program, I'm going to take notes. I'm going to note the current thread name, and I'm going to put it in a list, so in a set, so that it'll be deduped, right? I won't have duplicate records in there. So I'll say concurrent skip list set, and then when I run the program, here's what I'm going to do. I'm going to do thread.sleep 100 milliseconds. So I'm going to waste time. This is just like calling input stream.read. And then if I'm on the very first thread of the 1,000, if I'm on the first one, and it could be anything. It could be if I'm on the 50th one, it doesn't matter, but I'm going to just do one. If I'm on the first one, then I'm going to add the thread name. Okay, so current thread.toString, add that there, and then I'll do this again. So I'm going to copy and paste this code. Terrible idea, right? I'm going to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So what I did is I'm sleeping for 100 milliseconds, and then I take note of the current thread name. If I'm the first thread, I sleep another 100 milliseconds. That's 200. Take note. 300. Take note. 400. Take note. So I'm sleeping 400 milliseconds, but I'm creating 1,000 threads, right? Operating system threads. And so now I want to take note of that. I'm going to write out what we observed. Okay, so let's go ahead and rerun this program here again. And you can see that in the life of the program, it was on this thread the entire time, which is bad, right? And this is going to become a big problem when we start maxing out that number, right? 1,000 threads, okay, fine. But what happens if we get 10,000 or 100,000? Well, as soon as we start doing that, we're not sharing, right? We're not giving up that thread for anybody else to use when we're making those requests across the network. And we're going to run into a thread starvation issue, right? So this is a big problem. So now let's instead of using regular Java threads that we know and have used for 20 plus odd years, 27, 28 years, instead, let's use this new virtual threads in Java 21, okay? Virtual threads are amazing. So I've made this 100,000. Let's go ahead and restart, okay? Restart the program. And you can see the program is finished already running. But you can see here that same code. Look at that. I added, 10 times more threads. But now it says it ran on the virtual thread 1267, virtual thread 1267, virtual thread 1267, but the threads themselves, the actual operating system thread, changed. It automatically changed after each blocking operation. So behind the scenes, we were running on one thread here. It then detected, we were running on one thread here. It then did a blocking thing. The runtime moved us off of the thread, put us into RAM until the blocking thing, like input stream and output stream.write and read, and thread.sleep, it waited for that thing to finish, and then it put us back on another thread. That first thread that we were on here on line 63, that one is now busy doing something else. So it had to put us on a different thread. That's why the name of the thread changed. It does this automatically behind the scenes for us, right? We didn't have to write. You didn't see me launch any threads here, did you? Like I didn't change the thread. There's no like, change to available thread or something like that, right? I didn't do anything like that. It just did it, right? That's amazing. And what that means is now I can have millions of virtual threads, but I still have the same number of actual operating system threads, but that's okay because I'm not wasting time on them. If I'm making a call to that Heroku service using my declarative interface-based client, I'm not sitting there wasting time. This is super valuable because now I get much better scalability. The same machine, the same code base that I had before, all I gotta do is change the kind of thread I'm using. And of course, this is pretty low level. Remember, people, friends don't let friends like write threaded code. You don't need to write code this low level. If you're going to use threads, first of all, you're probably not going to use thread.virtual. You'll probably use an executor service, right? This is what a lot of people do, is new virtual thread per task executor. This is the new executor in Java 21. It is not even a thread pool. It's just going to create new threads all the time. And you can use that just like you would any other executor service to submit the task. But even this is low level. Remember, we shouldn't be dealing with threads at all, right? This is too low level an abstraction. How many of you know Tony Hoare, H-O-A-R-E? Tony Hoare is he's the person that came up with the idea, the notion that null was a $1 billion mistake. And I think he was wrong about that. Obviously, PHP was the $1 billion mistake. But he also talked about threads. He said in the 1970s, by the way, he said threads are considered unsafe, basically. They're not a good way to build scalable concurrent systems. They're unsafe. They're dangerous. And he was right. That's 40 plus years ago. And he was right. And here we are still using threads. So let's not do that. I mean, most of the time we shouldn't be dealing with threads at all. If you're going to deal with threading, if you want concurrency, use a framework, use a system on top of that, like actors or sagas or reactive or whatever. But if you're going to use it, at least it's nice to know that this is very, very convenient. But again, most of us aren't going to use threads at all. And if we do, we'll start with this. But the thing is, in your typical Spring application, there's lots of places where you might have executor services, right? Your web container, your integration layer, your data. I mean, all these different things might have executor services, your Spring Batch code, right? All this code might require its own custom executor service. So friends, I don't want this executor service. I don't want to have to configure this all over the place. So if you're using Spring Boot 3.2, which comes out when? You're right, next Thursday. Good. If you're using Spring 3.2 in Java 21, just specify Spring Threads virtual enabled equals true, and we will do the work for you. So now, everywhere in the platform, everywhere in Spring that you could be using a thread pool, a virtual thread pool to get this amazing scalability, we'll just do it for you. It just happens for free. So now Tomcat, now that declarative REST client, all those things where you could be blocking a thread, it's now doing a virtual thread. So it's basically free. You're not wasting time on the thread. The thread is able to handle other work in the system in the meantime. Isn't that amazing? Okay, good. So now we've got our declarative client. We've got our JDBC client. We've got our data access layer. We're moving to virtual threads. Make that a Lambda. That's much better. Good stuff. We got free, easy virtual threads. I think and we got our controllers. We got our all this kind of stuff. I think it's time to talk about moving this thing to production. And friends, here, what I want to do is I want to package the application up to be as efficient and production worthy as possible. And friends, it's worth mentioning, if you have a question about how to package an application for production, then of course you're going to use build packs. What is this? Buildpacks.io. All right. Cloud native build packs. This is a way to containerize your application. And it works with Java applications, .NET, Ruby, everything, right? Remember, friends don't let friends write Docker files. Don't do it. Use build packs. This is a super easy way to do it. There's a CLI that you can use if you want, but if you're using Spring Boot, you don't even have to use a CLI. You can just do maven Spring Boot :build -image, or if you're using Gradle, you can say Gradle W build boot image, and that'll create a Docker image for you out of your application. You don't have to configure anything else; it's already there using build packs. Now, I'm not going to do that because this is not new. I just want to point that out. Build packs are awesome. They're just a much better way to take an application and get it to production without having to worry about the pain of writing a Docker file. Because by the time you finish writing that Docker file, it's probably already got a security vulnerability. Don't do it. Use build packs. It represents the collective wisdom of tens of millions of deployed Java processes over more than a decade's time between Cloud Foundry and Heroku. So it's a much better choice. Okay, so now the next thing is I want to make my application as small and efficient as possible. And friends, it's worth taking a moment here to appreciate just how amazing Java already is. And I think this is typified by this great blog here that was on the New Stack in 2018 before the COVID pandemic, or BC. And this blog asked the question, which programming languages use the least electricity? And you can see here that the results are pretty telling, right? If you look at this table, comparing energy, for example, you've got C, and C is the most efficient for machines, not for people. Not for people, just machines. It's the most efficient for machines, okay? You've got Rust, zero cost abstractions, good stuff, well done. You've got C++, disgusting, moving on. And then you've got Ada, who cares? And you've got Java, and Java's 1.98, but let's call it 2, okay? 2.0. So we're gonna, just simple math, 2.0. So we can say Java is twice as inefficient, right? Or more, or better, C is twice as efficient as Java. Okay, same page, everybody. We're on that. We all agree. So one is 2 times less efficient than the other. Okay, good. We've got other entries in the list. We got Swift. I got Haskell. You got Go, Away. You've got JavaScript and TypeScript. By the way, how is JavaScript like 4 or 5 times worse than TypeScript? I do not understand this. How? Anyway, moving on. You got these disgusting languages, not talking about them. And you got JRuby. By the way, the Ruby implementation on top of the JVM is almost a third more efficient than the C implementation of Ruby, right? The JVM is amazing software. And then, of course, you've got this. And this this really hurts me. I love Python. I use Python all the time. I've been using it since the 1990s. I'm a huge fan. And yet, this number is also problematic. Like, it's really bad, especially when you consider the rise of AI, right? Like, think about this. This is 76, and that is 2, right? 2. So 76 divided by 2, right? I'm not great at math. You know who is great at math? Python. So 76 divided by 2, that's 38. So that means that if you wrote a program in Java, and then that program, if that program used a little bit of electricity, and that electricity came from a factory that created carbon that went into the atmosphere, and then it went and trapped a little bit of heat in the atmosphere, and that killed 1 tree, then the equivalent program in Python would kill 38 trees. That's a forest. Like, that's way too many trees. You know what I'm saying? Like, that's a big number. We really need to kind of understand what that is. That's worse than Bitcoin, right? That's just super bad for everybody. So anyway, I don't want to talk about that too much. I'm just saying Java is really, really, really good. It's already very good. But the question then, of course, is how can I make it more efficient? There are 2 ways to do this. One is, if all I care about is startup time, right? Then one effort I can use is Project Crack, right? Coordinated restore at checkpoint, right? Coordinated restore at checkpoint, right? Introducing. So there's this one right here. And Project Crack is a really good way to take a snapshot using CRYU, C-R-I-U, which is a Linux technology. It's a great way to take a snapshot of your Java program. And then when the program, you take a snapshot, write it to disk, and then use that snapshot to instantly turn on the machine again, turn on the program again, and skip all the initialization. It'll just go straight from 0 to fully configured almost instantaneously. And this is a technology that you can support on Linux. It only works on Linux, so I'm not going to show it to you here because it takes a lot of time. But it's really good if you're trying to do like a Lambda or Knative or scale to 0. This is phenomenal, and it requires almost no changes to your code. You run the program, take a snapshot, save that to disk, move that to another computer, and then use that to start up the same program instantaneously. And in Spring Boot 3.2, we have support for Project Crack. So that's part 1. The other option, and by the way, when does that come out? You're right, next Thursday, 3.2. Thursday, okay, 23rd of November. So the next thing that you might want to do is to take advantage of native images, GraalVM, right? GraalVM is an open JDK distribution with extra utilities for native compilation. And so we're going to use that here. We've got support for it in Spring Boot 3.0, actually. So we don't even have to do, it's already been there for a year now, right? But I'm just going to show it to you. So skip tests, native compile, and we're just going to let that run in the background. And the problem, of course, with this is that it does take a little bit of time. And that's my least favorite part of this process, is that it does take a bit of time, even on my fast machine. And so now I finally understand this famous cartoon, this XKCD cartoon. The #1 programmer excuse for legitimately slacking off is my code is compiling. The boss says, hey, get back to work. And the programmers say, oh, code's compiling. Oh, okay. Carry on, right? I get this joke now. I don't want to get this joke. I don't want to, but I do now. I thought this is just the C++ people, and it just makes me very sad. And eventually, I get very bored very easily. I do these long-running compilations, and I'm sitting there waiting for the compilation to finish, and I start to hear music. When I'm bored, I'm just sitting there waiting. Oh, I get so bored, and I just hear music in my head, like elevator music. And I said, gosh, wouldn't it be great if everybody could hear elevator music? And so I went to Oracle. It doesn't hurt to ask. So I went to Oracle and I said, hey, Oracle, please play elevator music during the native image compilation process. And I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do. I really do. I appreciate their work. They're amazing. And I got some great responses, including this one from our friends over at Red Hat, Andrew Din. He's a distinguished engineer on the Red Hat Java team, Open JDK project reviewer, Byteman project lead, a GraalVM developer, etc. Really amazing. And he said, please, can you make it this elevator music? This is elevator music that from the 1990s Pierce Brosnan movie, the James Bond movie called GoldenEye, that had a video game on the Nintendo 64, and the Nintendo 64 released a soundtrack album, and then this is one of the tracks on that soundtrack for the video game, for the movie, okay? I'm not going to play it for obvious copyright reasons, but it's pretty good. Pretty good. I like that. Somebody else said, I'd add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea. I mean, even my stupid microwave will make a ding sound when it's done cooking. Why can't my compiler do that, right? That's a great idea. I like this, okay? And then I got this one. Thank you for the feature request, Josh. And this is from, by the way, Fabio Niephaus. He's a researcher on the GraalVM team at Oracle Labs. He's a doctor, one of my favorite doctors, along with Doctor Who, Strange, Seuss, Subramaniam, Sire, DeVolder, and Pollock. And he said, thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Yes, okay, I like this. Go on. Anyway, he continues, I have prototyped the -- Josh Long mode. So friends, here's what that would look like, right? You're going to run the native image compiler, and then you're going to say -- Josh Long mode, pass in the class that you want to turn into a native image. It would print out that that there's music playing too, and it's brought to you by Josh Long. I'm Josh Long, by the way, and that's great. But this is a picture, so you can't hear the music, people. But don't let that stop you. You should imagine that there's music right now. Okay. So anyway, it'll print out the text, and then you'll hear music, and then you're kind of wondering what's going on, and you're still waiting. But at least you got lively music. Maybe you want something nice to look at. So then it'll show you this, right? And I think that would be a really good addition to the compiler. I'm sure that it'll get merged anytime now. I forgot what we were talking about. Oh, right, the compilation. Yes. Okay, so that actually, oh, this is awkward. That finished many minutes ago. That is very bad. Okay, so we took a long time. Sorry about that. So let's go ahead and run the binary. Okay. Service. It's 86 megs. That's everything. I don't need the JRE. I don't need anything in the class path. That binary is Opta is a statically linked self-contained binary that will only run on Mac. And I can build on Linux, and I can build a binary that only runs on Linux. And remember, same if it's architecture specific as well. This won't work. This probably won't run on Intel Mac, for example, because I'm using Apple Silicon at the moment. So, okay, native binary, boom. I started it up, but of course there's a port conflict because my existing program is still running. Start that up. Here we go. Okay, now it's saying, oh, you forgot to configure the database, and that's true. So let's go over here, friends. Desktop, talk, and you can see I've got this this script here, and what that's going to do is it's going to create credentials, environment variables as credentials as environment variables, and then run the binary. It's going to talk to a database with username, password, and schema name BP. Well, that database I have to start it up, right? Remember, before test containers was doing the work. But now I actually need something real to stand up. So I'll say Docker compose up. It's up and running. Okay. And then I can do run. Boom. All right. So the program with 100,000 threads started up in 0.116 seconds. And you can see we got Project Loom. So we got great scalability. It's super lightning fast. But much, much more importantly, certainly for me anyway, because remember, you can use Project Crack if all you care about is startup time. But for me, and by the way, the startup time on Project Crack is usually even faster, right? It might be 0.05 seconds. You might get like 50 milliseconds instead of 100. But what I care about instead of startup time, because this is a stateful, long-running program, so who cares? But what I care about is this. This is the process identifier. So I'm going to look at the RAM that it's taking, and you can, resident set size. Oh, I created a 100,000 threads. That's why. But normally, if I just create 10,000 threads or something like that, let's see if we do that again. Yeah, normally this is a little embarrassing. If I normally create just a regular amount of threads, 10,000 or 1,000, this is normally just going to be, maybe 100 megabytes of RAM. You know what I'm saying? And in fact, if I don't create threads at all, if I just use a regular app, it'll take 100 megs of RAM. So this is a very, very good number. But this is, by the way, divide this by 1,000. I should say this is the resident set size is measured in kilobytes, so divided by 1,000. So the number is actually 483 megs of RAM, and that's with 100,000 threads, right? Each of which has stacks and memory and all that stuff. Okay, so now, my friends, we've got applications that take a tiny fraction of the RAM that they would have taken before, a very, very small, like 10% or 5% of what you would have normally spent for the equivalent program. It starts up lightning quick. We can use Project Crack or GraalVM. We've got the nice fluid DSLs, the REST client, the JDBC client. We looked at declarative client interfaces. We looked at Project Loom. We looked at data-oriented programming, and we've just begun to scratch the surface. We haven't really looked at everything, but I'm afraid, my friends, that we're just about out of time. So I want to say thank you so much for being here today. I know there's a lot of choices for you, and you could have been anywhere, but you chose to hang out with me, and I really appreciate it. Happy Thanksgiving to those of you who celebrate, and I appreciate you. Have a great weekend and a great day.
Thank you, Josh, very much. It's just amazing. And as you hear during compilation time elevator music, I think we can listen carefully and listen these applauses which comes through the air from all around the world, from our audience to you. Thank you very much for being today on Java Conference.
And I really want to read one single comment from our comment.
Okay.
It's like we're watching God playing with their own toy and enjoying every bit of it. This is a fantastic comment.
Thank you very much. Yeah, thank you. Spring is it's if I can do it, anybody can do it. It's amazing, So
yeah, that's super awesome. So Josh, thank you very much. We don't have a lot of questions. Basically, I think people just amazed and running, changing Java version to 21 if they haven't did it previously.
Yeah, and if you have questions, friends, Java 21. That's Java 21 and Spring Boot 3.2. But if you have questions, again, Starbucks fan, and here's my email, josh@joshlong.com. Reach out. I'm happy to help, happy to engage, happy to talk.
Yeah, and I can confirm that I wrote a couple times mail to Josh and he responded. That was just amazing for me as well. So Josh, thank you very much. Thanks for being on Java Conference, and have a good day. It's on the morning for you, so thank you very much.
Bye.
Thank you.
So we are moving to the closing of our conference. A bit sad, but I still think it was awesome. So guys, please write us your comments. Did you like the conference? I hope you liked it. I hope it was amazing. Alexander, what do you think about our conference?
Well, that's fantastic. You know, we covered many different topics today, and I can speak about today, and next we'll talk about all the around the conference, because we've been talking about the most popular technology nowadays. Well, for Java developers, obviously, it's Java, Spring. We've been talking about Micronaut. We've been talking about way of thinking, proper way of thinking, and even about deployment and service meshes. So that's fantastic. We covered the full stack, almost DevSecOps. We've been talking about everything today. That's amazing.
Yeah, that's super cool. And we start with Grace Janssen with great new topic, I would say, in the engineering world about new platform ops, and finishing with great is Josh Long. And in the middle, we had super nice talk from Evgeny Borisov for 3 hours, and all our other speakers. Yeah, we always like highlight only 3 top speakers, of course, but still we had 10 great speakers on our conference, and I want to thank all of them. Well, basically, let me show the presentation I have for closing. So guys, this was Java On 2023, 3 days. This conference was delivered to you by 3 communities, majorly by MGC, JaCoV, and Mini community. We have informational partners. It's Ware community, it's EPAM, it's DevBuy, and Community Day. These are communities who helped us a lot during this conference with informational support, etc., etc., etc. Thanks to all of them for helping us. A reminder that we still have our Instagram and we still have our X/Twitter, so may subscribe. And some fun facts about that. So, Alexander, before I proceed, may I ask you a question? How do you think, how many people watched us on YouTube?
I think not less than a few hundreds. Definitely a few hundreds. It should be nearly 1,000.
You will be amazed. We have on our conference around 3,000 registrations and around 5,000 views on YouTube, and it's 56 countries. So yeah, we don't know how many unique members still, because YouTube takes 2 to 3 days to process all the data. But yeah, numbers is amazing. And thank you guys. Thank you to all of you who were with us for these 3 days. And also I want to thank guys who joined offline. So these guys, you may see their pictures in Georgia, in Spain, in Lithuania, in Turkey, and in Hungary. So thank you guys a lot. Thanks for making this. That's really cool that Java On can make offline people gathering together. Also, as I remind you during the conference, we had online activities, and I'm ready to announce the winners of our online activities. So for short Java quiz, which were made for us from Debrecen Java community, the winner is Ivan Babanyan. For Cinematic Universe quiz, which were made for us by Lithuanian Java community, the winner is Christine Grace de Paz. Sorry. And for sorry guys. And for photo challenge in Instagram, the winner is Munir Ismailov. Thank you guys a lot. We will contact you soon. I hope not earlier than next week, but we will contact you and tell you how we will move forward with your prizes. And of course, I want to say huge thanks to people who really deliver this conference to you. So we will start with special thanks to Andrei, Vadim, and Evgeny, who joined us on dry runs and on conducting the first day of this conference. Thank you very much. And our Java On team. These are people who making this conference for you. We were working since April this year. Deliver this, let me name these guys. It's Tatiana, Anastasia, Maxim, Irina, Vladislav, Yegor, Alexander, Mariana, Volha, Alexander, Anastasia, me, Roman, Igor, Ludmila, and Hanna. So these guys, they deliver this conference for you. So I hope you share with us applauses and your thanks. At the moment, I cannot see the chat because of sharing, but I hope you like this conference. And of course, see you next year. So this was Java On Conference 2023. I want to thank Alexander, who was co-host with me today. So thank you, Alexander.
Thank you, Roman, for having me today. I really enjoyed the sessions today.
Sure. Thank you very much. So I will say goodbye to you. And so this was Java on 2023. I hope you love it. Share with us your opinion. We will send you feedback form, and hope you will send us some warm words on what do you like, what do you like not so much. So thank you very much. Saying this, of course, Java is still on, but for now, Java is off.